About a 2-minute warning till we begin. Right, it's about 1 o'clock. We'll give it one more minute, but a quick PSA. If you are registered for the Amazon Web Services training on deforestation and forest degradation, you should make your way to room 3131. They will be getting started soon as well. Thank you. All right. I think we can begin now. I would like to welcome you on behalf of the Earth Prediction Innovation Center, EPIC, and the Unified Forecast System to the second annual Unifying Innovations in Forecasting Capabilities workshop. Thank you so much for joining us here, whether virtually or in person. I'm excited to see many faces that I have, of people that I've worked with. I'm excited to see many new people that I will have a chance to get to know this week. I guess to begin with, my name is Jillian Petro. I'm the main technical writer for EPIC's, for the EPIC program. Nice little picture of me. You might know me from my work on various repositories that EPIC either manages or collaborates on. But in any case, I'm excited to be here today, emceeing for you and introducing all of our speakers. As I'm sure you know, we are here today to see how we can best collaborate and move forward on enhancing the unified forecast system, and from there also see how we can accelerate innovations and how we can measure the impact of contributions to the unified forecast system. Before I introduce our illustrious speakers, there's a few thank yous and housekeeping items to take care of. So I would first like to thank the EPIC program for spearheading this event. Also, a huge thank you to Raytheon and UCAR, who have been instrumental in coordinating the logistics for this event. Also, a thank you to the organizing community and committee. We wouldn't be here today without their hard work over the past several months. Moving on, I'm going to give a brief overview of the agenda for today. So we're going to start with opening remarks from a few of our community leaders. From there, we'll move into a talk on the state of UFS science from our UFS research to operations co-leads. And we want to hear from them where we stand science-wise in terms of achieving the vision and mission of EPIC and the UFS. This will be followed by a talk on the use of the UFS in teaching and research So we'll hear from academia about that. And then just before our break, we'll hear about the role of partnerships and how we can better establish partnerships with different elements of the community to improve the unified forecast system and get more people participating. We will then have a 30-minute break where you'll hopefully be able to chat with people about the ideas you've been hearing, stretch your legs, and that will be followed by a panel on the importance and need for diversity in community modeling. We'll hear about what NOAA is already doing and what we could be doing better. Then before we adjourn for the evening, we'll hear from our inaugural class of Wings Dissertation Fellows. We'll welcome them and hear about their research. And then once we adjourn, everyone is invited to a networking dinner at the Avanti Food and Beverage Restaurant. Address is there. But we'll post that again, I think, towards the end of the day. So housekeeping items, more housekeeping items. We are live streaming this event. If you have a mic, make sure to turn it off when you're not speaking. If you are not comfortable being recorded, I suggest staying towards the back of the room and out of sight of the camera. No event these days is complete without a hashtag. So if you're sharing photos or impressions, ideas from the conference, then feel free to add a hashtag UIFCW23 on Twitter, Instagram, Facebook. Also, give us a follow on Twitter, Instagram, Facebook if you're on there. That would be great. We can continue the exchange of ideas. All right. I think I missed one. Oops. Oh, yes, the Wi-Fi. There we go. Very simple. UCAR visitor is the Wi-Fi. There's no password required. You do, I think, need to press a connect button that should pop up. So there we have it. And then last slide is the UIFCW event guide. It has the agenda for the full workshop. It has information on trainings, has speaker bios and abstracts. So if you're interested in finding out more about the different presenters and their work, you'll get a more thorough summary in there than you will in the interest of time from me up here. All right, the event guide was also emailed out last Thursday, so if the QR code isn't your thing, check your emails. If you need to use the restrooms, they're located out that way and back, so to my left, your right, and back. And then also, this is Center Bay. For any events that are happening on the north side, that's this way. The south side is that way. And I think that's about it for the little details there. So we can move into beginning the conference. Without further ado, I would like to introduce Dr. Dorothy Koch, Director of the Weather Program Office. She will be introducing our next speaker, Dr. Michael Morgan, for us. Thank you, Dorothy.
All right, good afternoon, everybody. So it's my great honor and pleasure to introduce Dr. Michael Morgan, who is the Assistant Secretary of Commerce for Environmental Observations and Prediction. In this role, he is responsible for providing agency-wide direction with regard to weather, water, climate, and ocean observations, including both in situ and satellite, and the process of converting observations to predictions for environmental threats, aka modeling, yay. Dr. Morgan was a professor at UW-Madison in the analysis, diagnosis, prediction, and predictability of mid-latitude and tropical weather systems. He served on the World Meteorological Organization World Weather Research Program Scientific Steering Committee, He was a member of the board of directors of the AIP, American Institute of Physics, and as the chair of their public policy advisory committee. He served 2 terms on the board of the trustees of UCAR and was the division director for the Division of Atmospheric and Geospace Sciences at NSF. He was also AMS UCAR Congressional Science Fellow, and he is a fellow of the American Meteorological Society. So we're really lucky and fortunate to have Dr. Morgan here with us for the day and to help us open this conference. Dr. Morgan.
Thank you and good afternoon. I'm really delighted to be here, and I thank the EPIC program for their organizing this this event this week, as well as the invitation to come and speak at the opening of this program. Unfortunately, I was unable to join folks this morning on the GitHub activities and the land surface modeling activities. I was eager to pull out my laptop and begin to get back into some science for a little bit, but unfortunately, I forgot that I hadn't updated Xcode on my laptop, and I didn't want to get it in a situation where I couldn't actually do the other work that I have to do back in DC. So I'll try it at a later time. But anyway, good afternoon. Welcome to Unifying Innovations and Forecasting Capabilities Workshop. This workshop emphasizes the significance of collaboration across different sectors. It provides a platform for participants to share their insights, experiences, and expertise, fostering a culture of cross-sector collaboration. And collaboration is really the key word here. In terms of the modeling enterprise, it's not just one group does it alone. It really involves working with and across the entire weather enterprise in facilitating the development of our models, the testing of our models, and defining the requirements for the modeling systems that we have now as well as those for the future. We're seeking these innovative solutions and improved forecasting capabilities. Again, I'm delighted to be here today. I really have the opportunity to talk about 2 high priority activities for me in my capacity as Assistant Secretary. As Dorothy Koch had mentioned, my responsibilities are providing agency guidance on how we transform observations into predictions of environmental threats. And while there is certainly the predictive capability there, I look at that link between observations and prediction as the data assimilation component of it. And I think that's really a key area where NOAA going forward should be making some significant investments. I mean, a lot of the forecast advancements we've seen over the last couple decades have come from not only the model development, but in large part due to our more effective use of observations. And so it's really great to see some training and some introduction to the land surface modeling assimilation system that's being coupled into the, as part of the EPIC system, the UFS system, being described and discussed earlier today. If you look at for NOAA and look at the value chain that links our observations to elements of societal benefit, I think one of the key links in this chain are this model analysis and forecasting aspect, right? Taking those very fundamental observations that underpin everything that we do, transforming them into analyses that can be used to initialize our numerical weather prediction models, in fact, our Earth system prediction models, to generate forecasts and then look at the outcomes, the societal benefits, and provide those useful service delivery for societal benefit. That's really a key focus of some of the discussions you've already had today and are going to be continuing going forward. And I think that's really critical for NOAA to be making investments in. Our modeling infrastructure, certainly the UFS, as we'll describe in just a few moments, is really becoming robust, and I think the community of users here and the growing community that we're going to be seeing are going to make significant advancements in the models, but also we're going to see a real need to effectively use our data in better ways. So a few years ago, NOAA conducted a holistic strategic review of the entire production suite at NCEP. And following the recommendations for this review, they provided a roadmap to consolidate its 21 standalone operational forecast systems into 8 applications via a unified forecast systems approach, or the so-called UFS, which many of you are familiar with. It's a community-based, coupled, comprehensive Earth modeling system, and the UFS applications span local to global domains and predictive timescales from sub-hourly analyses to seasonal predictions. And it's designed to support the weather enterprise and to be the source of NOAA's operational NWP applications going into the future. The UFS community includes researchers, developers, all of you that are here today, and those that are joining us remotely. and users from NOAA, educational institutions, federal agencies, and the private sector. The UFS supports research and development in the community and accelerates the transition of research successes to operations. The applications here agreed upon numerical forecast system elements, including the Earth system model components, atmosphere, ocean, sea ice, etc., as well as observational processing, pre-processing, data assimilation, forward forecasting, ensemble and probabilistic processing, and post-processing. These applications also share agreed upon infrastructure, such as model coupling tools and workflow software, Now enter EPIC, right? EPIC's vision is to enable the most accurate and reliable operational numerical forecast system in the world, but its mission is to be a catalyst for the community research and modeling advances that continually inform and accelerate our advances in prediction and our predictive capabilities. So this community modeling development environment, providing code that's cloud ready, that's another aspect of where we're going. Ensuring that there's an engaged community and clear research and model transition priorities being well established to get to operations are key pieces of EPIC. For EPIC, so that's the EPIC piece there. And so one of the things I'm going to get to is sort of the success of EPIC, or an early success of the UFS in just a moment. But the other piece that I want to point to that's important here is the work that we have ongoing with the Joint Center for Satellite Data Assimilation. It's a multi-agency research center to improve the use of satellite data for analyzing and predicting weather, the ocean, the climate, and the environment. Its mission is to accelerate and improve the quantitative use of research and operational satellite data in weather, ocean, climate, and environmental analyses and prediction systems. The Joint Center supports a number of projects, including JEDI, the Joint Effort for Data Assimilation. And these JEDI scientists and software engineers are working to provide a unified data assimilation framework for research and operational use. The different components of the this is for different components of the Earth system as well as various applications. The project's main objective is to reduce and avoid redundant work within the community, increase the efficiency of research, and assist in the transition from development teams to actual operation. And so JEDI really forms the basis for what's going to happen, or how we're going to do data assimilation operationally within NCEP in the years to come as the software continues to get built out. Now, the importance of data assimilation, you can go back and look at some key documents that have emerged over the last couple of years. In December of 2021, the Priorities for Weather Research, a so-called Power Report, identifies observations and data assimilation as one of the 3 pillars to enable a weather-ready nation. And they identify the need to advance the state of the infrastructure and science for operational data assimilation to realize improved operational predictions and better meet agency mission. Research indicates that improving DA will be key for improving our forecast. The UFS needs to complete its transition to JEDI so that it will be more clear how the community may contribute to data assimilation. And I really think this is something that should be prioritized within NOAA, the UFS, and the Joint Center. What does success with an EPIC look like? One is going to be the demonstrated facilitation of strong collaboration within the UFS community to nurture an inclusive and diverse modeling community of practice across the weather enterprise. The development of a publicly accessible and end-to-end testing and development environment on the cloud. I know that's going to be a significant challenge for us going forward, but that's something within my office we're working on, looking at HPC requirements as well as those for the on-prem systems, but also for the cloud where we think collaboration is going to be enhanced. So this environment is going to support both pre to post-processing for NOAA's core UFS weather model applications. And finally, innovations brought to improve UFS performance, and this includes forecast skill and computational efficiency, and tracking those via a number of metrics. So speaking of success, an early success of this new framework, this UFS framework, is the Hurricane Analysis and Forecast System, or HAVS model, which was put into operations just the end of last month, June 27th, and it's going to be running alongside existing models like the HWRF and HMON for the 2023 season before replacing them as NOAA's premier hurricane forecasting model. The HAVS is the first regional coupled model to go into operations under the UFS. It was developed through community-based collaboration and the streamlining of operational transition processes. HAVS was jointly created by NOAA's National Weather Service Environmental Modeling Center, Atlantic Oceanic Meteorological Laboratory, AOML, and NOAA's Cooperative Institute for Marine and Atmospheric Studies. HAVS is also the first major forecast model implementation using NOAA's updated weather and climate supercomputers, which were installed just last summer. HAVS would not have been possible without the speed and power of these new supercomputers on what we call WCOS2. Among the successes of this, over the last couple of years, HAVS has been running, an experimental version of HAVS has been run from 2019 to 2022, and it showed a 10 to 15% improvement in track predictions compared to NOAA's existing hurricane models. HAVS is expected to continue increased forecast accuracy, thereby reducing storm impacts to lives and property. And here are some other metrics of forecast success with the HAVS. You can see many of these boxes are in the blue or green category. Some places where it may currently lag behind the HWRF, but we hope to see those improvements forthcoming. But this is really a great advance. It shows that the UFS, the notion of having this UFS, this unified forecast system, having a common dynamical core underpinning what we're doing model-wise, this is working. And this is something that will soon be released to the EPIC community for further advancement, and testing and advancement is part of the process that EPIC goes through in moving our models forward. There are a number of strategic directions that NOAA is going in. We have a 10-year NOAA modeling strategy that perhaps will be delivered sometime later this year in the fall. And this is really going to focus on identifying various mission-critical modeling activities that we should be engaged in. And these are centered around things like the unification and model consolidation, which is already part of the UFS notion, open science, the inclusion of our community, end-to-end modeling, development of a workforce, and ensuring that the appropriate and necessary HPC resources are made available, not only to the NOAA scientists, but also looking to the community to make sure they can help collaborate in our model development. And this document that will be forthcoming will guide NOAA leadership in prioritizing research, resources, and people over the next decade. As I mentioned before, data assimilation is another key area where we want to see advancement. And there's a data assimilation strategy that's being developed that'll be coming out later than the modeling strategy, but these are two things that are really important to me in establishing the direction that we're going to go and making our investments in data assimilation. I mean, fundamentally, it comes down to our being able to use the observational investments that we make to the fullest, to get the greatest information content out of the observations that we have, be able to more agilely assimilate new observations into our models, and to also help in determining what should our future observing system look like. So data assimilation is really going to be a key component, and I think working with JEDI, or the Joint Center with the JEDI software development, and I acknowledge that, I mean, it's not only other agencies, but even the UK Met is contributing to this effort. There's a global interest in this particular activity. But I also mention here opportunities to build a workforce. So at some point in the next few days, hear about some of the work that NOAA has been doing to establish opportunities to advance data assimilation research and education while developing a long-term strategic partnership with the academic community, NOAA, and the broader weather enterprise in advancing data assimilation methodologies to improve NWP and Earth system prediction capabilities. I sort of urge you to sort of look for these announcements of opportunities in the near future. I can't say more about it at this point, but there's work that we've been doing that you'll see emerge, I think, shortly. Finally, I'd just like to say thank you for your attention. Thank you for your engagement in this really important effort. The development of our unified forecast system and the work that EPIC's doing, I think, is going to be central to our modeling and assimilation enterprise for the next decade, if not beyond that. So thank you very much for your attention. I'd be happy to questions or comments or concerns if anyone has any.
Thank you very much for your talk. Very informative. You mentioned the Joint Center for Satellite Data Assimilation, and it's one of the other 12, well, total, yes, test beds across NOAA. And I'm thinking about the Developmental Test Bed Center has worked very closely with EPIC, more on the flip side. So it's modeling and data assimilation. Right. So I just want to make sure that, you know, that is
brought up.
Brought up because we're all working together, and so the NOAA test beds, the NOAA labs, EMC, you know, all the research projects, the community, et cetera. So team effort. So.
No, most definitely. I don't, I did not, by excluding that or not mentioning that fully, is not to discount the importance of our developmental test beds and the work that's being done across labs. I mean, in terms of the HAVS model development, you neglected to mention, GSL's involvement in running the models
Absolutely.
in regular periods. So I'm
Absolutely.
fully aware of that, and I really appreciate the work that
Okay.
everyone's doing in this.
Thank you.
Okay, thank you very much.
Hold on, I got a question.
Did get away.
Took me a little longer to get to the mic, you know. Yeah, so thank you for your comments today. One of the things that you mentioned was cloud, and everyone using a cloud environment. And so from that standpoint, of course, there are different cloud providers like Azure and Amazon. Do you have a sense as to preference for one versus the other versus, trying to be cloud agnostic, or, having two cloud, interfaces available for people to use? So if you have some comments on what that might look like, I'd appreciate it.
Right. I mean, at present, I can't say that we put our thumbs on the scale with one particular provider. Ultimately, it comes down to what are the resources, what are the sort of the software environments that the cloud providers can provide for our modeling needs, right? If we're looking at tools that might enhance our simulation or modeling capabilities, that might be specific tools that are developed by Azure, Google, or AWS in terms of machine learning types of code. I mean, they all have some flavor of that. What works best for the work that we want to do? So currently we have contracts with all three providers, and we're just going to work, as we move forward, identify which ones, or which one perhaps might give us the best benefit, because we recognize that there are some, complications in doing work in one environment and then trying to share it with someone doing work in another environment. But the great thing is our models are being developed so they can run in multiple environments, which is great. But how we share the data and the output from that across platforms is going to be a challenge. But that's something we're considering, but I can't offer a solution to you today. Thanks again.
Thank you very much, Dr. Morgan, for your illuminating remarks. Next, I would like to introduce Dr. Dorothy Koch once again, and Dr. Stephen Smith, who will also make some remarks about EPIC and the UFS. I invite you to view their full bios in the UIFCW event guide, but I will provide an introduction here. So, as I mentioned before, Dr. Dorothy Koch is Director of the Weather Program Office. Prior to that, she was the Director of the National Weather Service Modeling Division. And in addition to her work as Director of the WPO, she is Weather Portfolio Steward for NOAA Research and the Chair of the NOAA Modeling Board. She has a long history of contributions to Earth systems modeling, including at the Department of Energy, at Columbia University, and NASA's Goddard Institute, Director of the Office of Science and Technology Integration. And he is responsible for several programs: the Meteorological Development Laboratory, the Operational Proving Ground, the Modeling Program Team, and the Field-Driven Research to Operations Team. Steve has been with the NWS since 1993, and he has played a pivotal role in improving the transition of research to operations. He received the NOAA Administrator's Award and the Department of Commerce Bronze Medal for his work leading development, implementation of a multitude of decision support tools and guidance products to enhance NWS operations. With that, I would like you to welcome both Dorothy Koch, and Dr. Stephen Smith. Thank you.
So I guess I'm going first, correct? Yes?
Oh, okay, great.
Can you hear me?
Yes, we can hear you.
All right, thank you. So great to be here today. I'm going to talk about modeling within the context of Weather Service's last critical mile agenda. So our mission is very basic: provide weather, water, and climate data, forecasts, warnings, and impact-based decision support services for protection of life and property and enhancement of the national economy. So how do we do this in the Weather Service? Is really this trinity of efforts in a S&T space, environmental modeling, which we're talking about here for this whole workshop, social, behavioral, and economic sciences, and manifest largely from both of these in terms of tools and applications. So bringing this home to our mission in the National Weather Service, we've recognized that we must transform the manner in which we provide our forecasts and warnings by focusing on service delivery, infrastructure, and the last critical mile of our mission to address the following: adopting a robust, reliable, and community-centric paradigm for dissemination of life-saving information, exploiting cloud technology to enable our workforce to become more mobile, nimble, and flexible inside emergency operations centers in communities we serve, and investing in the last critical mile and providing equitable services that account for the changing demographics of society and the unique vulnerabilities of each community we serve. The need for this on-site service delivery and decision support is driven by our partners in the field who rely on our ability to provide critical life-saving information, not only for the big disasters, but for the day-to-day weather events. And so Weather Service is focused on establishing a whole community engagement approach for education outreach by applying social and behavioral science to save more lives and fully realize the vision of a weather, water, and climate-ready nation. So what do I mean by equitable services? So the cartoon in the center on the left-hand side is really sort of our legacy approach, which I would call the one-size services, where the apples in the tree represent our highly valuable forecasts, warnings, and so forth. And the communities are the stick figures that we serve. So we recognize that under a one-size sort of approach, that not every community, based on their unique character and vulnerabilities, can fully take advantage of this valuable information. So going forward, we're shifting the paradigm to what we call equitable services, which means that we customize what we provide so that every community, regardless of their vulnerabilities and unique character, can receive, understand, and act upon this highly valuable information in order to improve their outcomes. So this is definitely a marathon, not a sprint, but we're well on our way towards addressing this paradigm shift. An example of why a one-stop or one-size-fits-all paradigm doesn't really work is if you look at this sort of matrix based on warning types, we have two basic actions that we generally ask people to do. One is either shelter in place or evacuate. And we have two basic types of warnings, either long lead time in terms of hours or days, or short lead time in terms of minutes. And here are some represented examples of these types of warnings. The red box, wildfire, flash flood, is sort of the worst case scenario. We're asking people to evacuate in a very short lead time. So the problem with this type of an approach is that there's core assumptions about whether people can receive the warning. Can they understand the warning? Is it in a language that they can understand? Can they act upon the warning? Do they have the resources? Are people willing and able to evacuate? And do they have a place of safe shelter if they're required to shelter in place? And in many cases, vulnerable populations and communities, these core assumptions do not apply. So we see this playing out on a very frequent basis these days. Here's an example from Hurricane Ian, where despite a very accurate forecast of the landfall of Ian, we had over 140 people die, mainly due to drowning. A lot of them were elderly people. We know that elderly demographics are one of the most vulnerable for landfalling hurricanes. To test some of the assumptions about what people do in landfalling hurricanes, we've embarked on some innovative social science research. This that I'm showing, these two slides, were conducted by NCAR as part of a hurricane supplemental funding. And what they did here was to survey the same population of survey recipients at different stages before landfalling Hurricane Ian in 3 waves, and basically asked them, what did they do at these different stages? How did they prepare? What actions did they take? What information were they receiving? And so we basically were able to conduct this research based on the fact that the Hurricane Ian forecast for landfall was quite accurate out that far in advance. In other words, our environmental modeling, and this is even pre-halves, was quite good. And so we knew which populations to focus on and to test these assumptions. And we basically are starting to look at using these approaches as supplemental, almost like drop sounds before a hurricane, to understand what people are doing before these hazardous events, and we're looking into others. Another big underpinning in this last critical mile is understanding social vulnerability. This is a CONUS view of the CDC Social Vulnerability Index shown for the entire country, where the dark blue is the highest vulnerability populations. We see for different events that when you look at the lens of social vulnerability, it's not just a tornado crossing over a particular geographic area, but there are people living in these areas and they have different needs, and we may and most likely need to prepare them and provide different types of warnings in order that they can shelter in a place that is safe if they don't have one handy. This was from the 2 Arabi tornadoes that occurred in 2 different occasions just east of downtown New Orleans, remarkably similar tracks. Here's another example from this year where there was a life-threatening flash flood emergency near Fort Lauderdale, and you also see the very complex nature of vulnerability in the populations we serve. So to wrap this up, I just want to bring it home to the reason that we're all here this week looking at the UFS and EPIC, is that we need to, despite the fact that our models are quite good, they can obviously be much better. And we need the whole community contributing their intellectual capacity, their coding, their ideas to the UFS through EPIC in order to raise all tides. And we have a very broad waterfront to look at, everything from seasonal forecast system down to the Warn-On forecast in which to do that. So I want to encourage everyone this week to be open for sharing ideas in a psychologically safe manner so that we can all benefit from this. And I really hope that you will join the UFS community and participate in any way or shape or form that is comfortable and reasonable for you. Thank you.
Okay, so while they're pulling up the slides, I'll just say, up until half an hour ago, I thought Steve and I had half an hour, and we have 15 minutes. So I'm going to just scan through half of what I was going to say. And I had some updates from headquarters, and I also had some areas where I really want to hear from you during the course of this meeting. I want you to be thinking about and working on some things during the meeting. And to me, that's the more important part. So I'm going to skip very quickly through the highlights. Yes, Julian? Oh, we have till 2. Oh, okay. It keeps changing on me, Jillian. I'm getting very confused. Okay, very good. That helps. Thank you. So, and I appreciate the remarks from Dr. Morgan as well as Steve. I really think they really helped us get started here and actually covered some of the points I was going to make. Regarding the halves implementation, very exciting. We should all feel proud of this. And I think this is a real testimony to the fact that NOAA is serious about working with the UFS in terms of using it as a code base for our operational implementations. I mean, we've been doing this for a while, but I think halves is probably the most solid, exciting example that we have so far. And as Dr. Morgan said, everything's looking really good. We're going to hear more about it, I think, over the course of this week. But in terms of a forecast system, it's really quite good. So I think we should all feel proud of that accomplishment. Another highlight is the Weather Program Office had an innovation funding opportunity this past year. We've had some, real push from the community to provide more innovative, lower readiness level opportunities to the community, and so we did that this year. We're not quite at the point of being able to announce those awards, but they should be out very soon over the next few weeks. But I will say that most of those, by far, like 90% of the projects, are directly involving the UFS. So we're serious about supporting the UFS here. This is an older version of the slides than I had. Okay, that's okay. Because I also wanted to mention there will be a funding opportunity this coming year. It will be more modest, and it will focus on the climate testbed and fire weather opportunity. So just FYI, that will also be coming out in the next few weeks. So in terms of highlights from EPIC, the EPIC continues to provide UFS code releases, including data assimilation system, short-range weather system. There'll be another version of that coming out this fall, and as Dr. Morgan mentioned, EPIC will be also releasing the HAVS system. There's been a real cry from the hurricane community for that release, and so we've moved it up the queue for now. You know, this is how you get things done. If you want to have the codes released, you got to let us know. So that one's going to probably be next in line. We've been focusing on the short-range weather just because we want to really get one system out there working end-to-end in the cloud so that we can say that, you know, this is what EPIC is here for. So that's why we chose that system to start with for a variety of reasons that I think we've talked about before. But again, we do want to hear from you on that. In terms of community engagement, EPIC is pleased to announce, or we're pleased to announce, our first set of the WINGS WPO Innovation for Next Generation Scientist Dissertation Fellowship. Our 3 WINGS awardees are here, so you'll hear from them later today, and we're very excited to have this first set of students. They're celebrities here, so you'll get to meet them later. We also have our 3 LaPenta interns with us, and shown on here is Alikya Srinivasan. I put her on here because she's our first EPIC UFS student ambassador, so they'll also be available this week, and I'm sure you'll be hearing more from them as well. EPIC continues to have quarterly app training, CodeFest, and was involved in the NOAA Microsoft CRADA very heavily. A few highlights on infrastructure. So continuous integration, continuous delivery is available on Tier 1 platforms and 3 of the cloud service providers for both the UFS weather model as well as the UFS short-range weather app. Hierarchical testing framework continues to be advanced. I believe there's a poster, and you'll hear more about that. The open source cloud infrastructure as code, which allows you to create and run UFS apps, and the code is now, I guess, working. If you click on that link, you can find out more about it. And another activity that EPIC has been involved in is developing a software stack that works for both UFS and JEDI called SPAC Stack, which, again, if you click on it, you can learn more about it. But this is an important partnership that we have with the Joint Center. So I also wanted to talk about some of the new modeling activities that have gotten started involving the UFS over the past year. And Disaster Supplemental, FY22 Disaster Supplemental is supporting more hurricane model development. So I think that's mostly going to be developing version 2 of the HAVS. There's also some projects that are focusing on improving precipitation in the UFS, pretty much all end-to-end in terms of timescale of the UFS, as well as the GFDL models. And you'll see names on here. Those are people you can talk to. I think most of them are here, so if you want more information, you can look at the names in parentheses. We have a lot of new activity in subseasonal to seasonal, thanks to congressional appropriation and direction, new funding for the Weather Service to develop the seasonal forecast system. It's huge excitement for the UFS. We've been looking for that, and also to repurposing what we've been doing in OAR more towards partnering with the Weather Service on the SFS development, and also standing up a new climate testbed. I think, to me, that means focusing the climate testbed on working with the seasonal forecast system. And we're also been told to focus on particularly Western precipitation S2S forecasting in the appropriations language, but that's among other things. We'll be having some workshops coming up on S2S. There's going to be a NOAA-focused one so that we can all get our kind of programs better coordinated within NOAA. There's a lot of S2S activity all across NOAA. So we're going to have one conversation in September, and then after that have a more open community workshop with a date still to be determined. But on the way in between those, there's going to be some sessions at the AMS in 2024 that will be really relevant and will kind of be a first step towards that community meeting. We've also started to develop an atmospheric river forecast system. So we are using the Water in the West appropriation in FY23 to develop a UFS atmospheric river forecast model. So again, see those people in parentheses if you want to learn more about it. But the idea here is to create a model that has a high resolution mesh over the Pacific and the Western CONUS embedded in the global model so that we can get more of an extended range forecast of atmospheric rivers. And that model will be tested comparing against the winter events that we've had this past year with the atmospheric rivers. We also have some new activity in fire weather. So there was in the appropriations, in the BIL and the DRSA supplemental, there's been quite a bit of fire weather activities started and continued, as well as for the first time an appropriation specifically for fire weather. I think both Weather Service and OAR had some funding this year, and I expect that to continue. But in OAR, we have kind of split that between having a funding opportunity for the community through WPO, but also providing funds to the lab so that they can staff the test bed and some of their research activities in this area. Just real quick on the NOAA modeling team, Dr. Morgan mentioned earlier that we are developing a NOAA modeling strategy and also a data assimilation strategy. That's happening in the context of this NOAA modeling team, which is a team underneath the NOAA's Earth System Integration Board, formerly known as the Weather, Water, Climate Board. And the NOAA modeling team is coordinating modeling across NOAA. All the line offices are involved. At the moment, I'm the chair, and Brian Gross is the co-chair, so you can imagine there's some interest among some of us in the UFS. But those positions will be rotating. And indeed, NOAA modeling spans beyond numerical weather prediction, also climate, coastal, operational ocean, fishery, genomics. There's a whole range of modeling activities, and we talk about the whole span of that in the modeling team. So we have 3 working groups. I won't go through them here in the interest of time, but the strategy working group is the one that's mostly focusing on these NOAA modeling strategies. And I put Hendrik Tolman down here, but Danae is also here. Those are among the leads for developing that strategy. Kevin Garrett is leading the data assimilation strategy for NOAA. And as Dr. Morgan said, these should be available, I would say, by the end of this calendar year for sure. No pressure, guys. We have 2 other working groups. One is on enabling observations into models, so very relevant to Dr. Morgan's comments. The focus there. And then there's another one on trying to coordinate operational ocean forecasting, building the models and coordinating the models across NOAA. We're talking about potentially starting a group that would be on UFS, just to make sure that NOAA is coordinating about what our priorities are across NOAA in terms of investing in the UFS, and potentially one on advanced HPC. So this is the part where I wanted to, get some feedback from you on some things. And to start with, it would be really helpful for us, and us being, I would say, NOAA leadership, but also UFS leadership, to get a better, clearer sense of how you really want to engage with the UFS. And there's a range of getting engaged with the code and the guts of the code. And I think we've been making assumptions to some extent about what you all want, but we need to get better information. So I think the deepest is to be a developer, and even developer can mean different things. Do you want to tweak parameters, or do you want to put in a whole new parameterization? This is different levels of engagement. How interested are you in data assimilation, and is JEDI what you need to do your work? Post-processing and product development, is that your main interest? You want to run the model, maybe add a diagnostic, but not necessarily change the model itself. Testing and evaluation, and against what? Or do you mostly just want to run the model and train your students and do research with it? The reason we need to know this is because if you're interested mostly in number 5, and we're spending a large amount of our resources to make sure that anybody in the world can develop the system, then we're not targeting our resources in the right place. And so we want to make sure that we know how you really want to engage. So related to that is a question about how open does the code need to be. So the UFS is an open development modeling system, and we're very proud of that. But it takes a lot of resources for us to develop an environment where we can work with the public, together collaboratively in whatever space. And we're spending a lot of time and resources to make that happen. But if at the end of the day, you would really rather just have a version of the model that's been well tested and vetted, maybe it's in operations already, you don't need to be in there developing, then we're wasting our resources in a place that's maybe not the best way. It doesn't mean we can't bring you in. We find other ways to bring people in. But this is a kind of conversation that I think we need to have, and I've submitted a town hall on this topic that will be joint actually with NCAR, and I think DOE is also going to be part of that town hall. So think about it this week and talk to us about it, but also look out for that town hall. With respect to NCAR, we have been having a lot of conversations about community modeling and partnering more closely between the UFS community and the NCAR community. And so we have a series of workshops going on right now to consider how we might partner more closely with NCAR. And again, that could mean a lot of different things. It could mean we have joint meetings instead of, UFS meeting this week and, WRF MPAS meeting some other time, we would have a joint meeting. We could have the same testing framework so that we are running our own models, but we're testing them using the same kind of diagnostic tools and the same kind of testing environment, for example. We could have common infrastructure, which we sort of do, but we don't, we could be paying more attention to making sure that we're really using all of the same. And infrastructure can mean coupling, but it could mean workflow, and get a lot more, deeper into the guts of that infrastructure. We could have a common model. Oh my goodness, maybe we don't want to go that far. But if that's something that the community wants, that's what we really want to hear from you. So just want to let you know that those conversations are happening. Similarly with our, the NASA GEOS model is very similar to the UFS modeling system. Are there parts of the code base that the GEOS has that we could be working more closely with the UFS and the GEOS NASA community? We do have a project right now, particularly in the S2S framework or time frame, to make sure that we're drawing our data from the same data repository that's needed for reanalysis, reforecasting, and initializing the S2S system. So that's a really nice joint partnership kind of around the DA space with NASA, but we could do a lot more with them, again, if that's something the community would like to see happen. So I wanted to end with a slide on some challenges and things to think about this week. The UFS governance, I think we talked about this quite a bit last year, a whole year ago, and we're still not quite at the point of having our governance nailed down, but we're getting really close, and I'm confident we're going to get there. So I just wanted to let you know that there's ongoing conversations, and I think we're just so close to something that's going to be workable, so that should be unveiled soon. But we can't wait for that, I think, to start talking more about code governance, because we're having some real issues that are really, we're tripping over at this point. And I think we're at a point where we need to start enforcing the CI/CD practice within the code repositories. We need to designate and maintain an official repository, one official repository that will be provided and released to the community. And we need a commitment from NOAA Labs and the EMC to contribute to that official repository in order to avoid the divergence that's currently happening, I guess, for some of our codes between what we want to release to the community and what's going into operations. We're getting a mess, and we need some discipline here. So we are asking EPIC to work together with the cross-cutting teams in the UFS to draft a UFS code governance plan that will be approved by UFS leadership and NOAA leadership, so we can get ourselves all on the same page and literally into the same code. So you can talk to Neil, Hendrik, Mao-Yi, others about that over the course of the week. With respect to data assimilation, which again, Dr. Morgan gave a very nice intro, or, had some very good comments. We would like to be able to release JEDI as part of the UFS system, and unfortunately, it's looking like that's not going to happen anytime in the near future. It's looking like it could take months, potentially even longer, before we're really ready to release the UFS working in, JEDI working in any of the UFS systems. So given that situation, should we continue to release codes without data assimilation as we have been? So it's something to think about, talk about, and there will be plenty of conversations about that as well. So I wanted to end on the testbed point, since Mike Eck brought it up. I just added that quickly for you, Mike. So no, we talked about testbeds at the kind of during the workshop last year, and it's another thing I have to confess, we haven't really got a really clean answer to how the test beds fit with what we're doing with the UFS, except that we know we need to. And so let's bring it up at the beginning of the week instead of the end of the week and keep working on this. It's a kind of a workflow and a different kind of workflow context, how we actually fit the test beds, because they are community activities already, and they need to be integrated into the rest of the testing work that we need to do with the UFS. So with that, thank you. And do we have any time for questions for Steve or I?
Hendrik Tolman. So thanks, Steve and Dorothy, for making sure that we start with a real fire hose to begin with all the things we want to do. And so fantastic how you guys have brought it all together. The one thing I would like to mention, just in truth in advertising, what we're doing with the UFS and collaborating with the folks that live here. There's also a very strong link to the CESM. You mentioned AMPAS and you mentioned WRF, and I know it's very hard to not forget left and right, but effectively on one of the last CESM meetings, we made the statement between some of us from NOAA and from NCAR that you can almost say that these models are almost the same because they have almost the same infrastructure and just a few different components. So, and we probably still forgetting a lot of people that we collaborate with that just cannot be put in here. So just if you're like the UK Met Office, or if you're the Bureau of Meteorology or Meteo France, we work with all these people on components. So sorry folks if you feel left out. This is just, we don't have enough time to be completely complete in all the things we do together. Thanks.
Yeah, thank you, Hendrik. And you're absolutely right. We have lots of partnerships and lots of potentials. So yeah, on the CESM, they're calling themselves now WRF-MPAS, which confuses people because their mind goes instantly to the DICOR, and it's really kind of the new version of the WRF system. But our hope is that those two models will be using common infrastructure at NCAR so that we can keep our, align the UFS infrastructure with their infrastructure in both modeling systems.
University. Dorothy, I wanted to put in a plug for linking the first two sets of questions you have on the screen. So we've got search realm. We've published literally hundreds of papers using CFS and CFS v2. And I think you will find also in the short range weather forecast community the same desire to be able to use the operational code in a testing environment. So I think, four under your first bullet or your first question, and making operational codes available as soon as possible after the operational implementation as a public release would be extremely valuable.
Okay, and that's the kind of information we need. So again, I want people to walk up to me or, somebody who's more important than me, like, I don't know, who that would be, Brian or Dr. Morgan. Well, he won't be here all week, though. Otherwise, that would be good. But 1 through 5, where do you really want to see our energy? In terms of releasing the operational code, that's very different than releasing the developing code. So I know EPIC's always asking that question, but we need to do it in a more systematic way and really get our heads around where to place our energy. Yep. Thank you.
questions and the hopes and the vision that we have for the Unified Forecast System and all of our collaborating partners, EPIC and beyond. Next, we'll hear from our UFS Research to Operations co-leads, Dr. Vijay Talapragada, Dr. Jeffrey Whitaker, and Dr. James Kinter, whom we just heard from. I invite you again to read their full bios in the event guide, but as a brief overview, Vijay is the senior scientist at NCEP's Environmental Modeling Center, and he's responsible for providing strategic direction for implementing UFS framework for operational applications. Jeff is a research meteorologist at the Physical Sciences Laboratory at the NOAA Earth System Research Laboratories. His research is focused on the use of ensembles in weather forecasting and data assimilation. And then Jim is a professor of climate dynamics in the Department of Atmospheric, Oceanic, and Earth Sciences at George Mason University. He's also director of the Center for Ocean Land Atmosphere Studies and the director of the Virginia Climate Center. Please offer a warm welcome to our 3 UFS R2O co-leads. Thank you. Do you want me to stand here and move?
No, I can.
Okay.
It's only one button. I think I can manage.
Oh, there's the forward back and the pointer, laser pointer.
Okay, great. Thank you. Thank you so much. First of all, it's a great pleasure to be here and see a great turnout. Also, I wanted to give a tremendous debt of gratitude to my 2 co-authors, Vijay, who's down in the front here, and Jeff, who's in the back, at the back, along with an enormous crowd of people who did all the hard work of actually assembling this talk. I will show you all of their names a little bit later. It's a total random situation that we have 1 co-lead from Weather Service, 1 co-lead from OAR, and 1 co-lead from the university community. That was a joke, but nobody laughed, so whatever, that's fine. My jokes are not going to go well today, I can see that. Okay, so what I'd like to very, very briefly tell you about in terms of trying to hit this note of state of the science of the UFS is, first of all, talk about UFS as a community forecast system for both research and development, and of course, we'll be focusing, because of the nature of the project that we've been working on, focusing on the transition to operations. We'll also talk about 3 years of science infusion through the UFS Research to Operations project. We'll give you a little bit of information about where we stand relative to other systems in the operational world, as well as in the research world, and then finally end up with what is still needed to realize the vision. And I'll apologize up front, we're focusing on the R2O project because that's what we know best. We were asked to describe the state of the science of UFS, and we're going to spend a whole week doing that. So the reality is that this is just going to give you the briefest overview from the perspective of the Research to Operations project. So this was our inspiration more than 3 years ago at a meeting in College Park, Maryland, where we talked about putting together the Research to Operations project. It was originally inspired by a report that came out of the UCAR Modeling Advisory Committee. Fred Carr is here, who will probably remember this report very well, where we said 2 important things that are relevant for today. First, NOAA must be all in developing and deploying a unified community model. So those 2 words are being used very, very, we're viewing those as very important aspects of this project. Unified both in terms of a single model or single modeling framework really for covering a wide range of forecasting problems, and a community model, which means it's being used both by the operational side and the research and development side as a tool for making improvements and accelerating the way we get things moving forward. Also part of the inspiration was the selection of the FE3 dynamical core for the atmospheric component that came out of the Next Generation Global Prediction System project. The establishment of UFS about 3 years ago as well, and then this statement from the EPIC vision that you've already heard about, accelerating scientific research and modeling contributions through continuous and sustained community engagement. The status quo ante, the state that we had before all of this got started, was really more or less unmanageable, very costly to maintain quilt of forecast operations, which looked like this. And I'm not going to describe all the boxes in the chart, so don't worry, because that was then and this is now. But the point here is that each one of the boxes on here is a separate modeling application. And they have all these intricate dependencies that you see, the arrows connecting the boxes. So data and instructions are flowing from box to box. And this is just every time a change is made in one of the boxes that has arrows coming out of it, all of the other boxes have to be evaluated to see what's going on. So it's a very difficult to maintain program for concept of operations. So you've already seen this chart. You're probably going to see it a few more times this week. But this is our view of how we would like to go from the quilt forward to a very streamlined set of applications looking at different time ranges you see going across the page, and for different applications, different modeling applications, as well as what people need to be able to deal with weather and climate. Looking at weather and seasonal for the global scale, looking at hurricane and space weather, marine and coastal coming in the future, air quality that we're working on now, and flood and hydrological. And as you see going across the page, we've already looked at a wide range of time scales for the weather and seasonal, going from warn-on forecast at the shortest time range all the way out to seasonal forecast system, which Dorothy just mentioned is just getting its first infusion of funding. I'm just going to focus on the things in the pink box today. The rest of them are TBD. We're coming along with some of these things, more so for some of them than for others. But UFS is intended to be the modeling framework for all of these applications in the future. So you saw a much cooler version of this diagram in Dr. Morgan's presentation, what we've been calling the rainbow diagram. What you see on the left is, I think the number there should be 18 separate applications that run from global applications near the top to regional applications in the middle to then specialized applications like coastal, Great Lakes, hydrology, and space weather towards the bottom. Each one of these, as I mentioned in the quilt, is a separate application with separate data flows. And our vision is that on the right, we get all of that down to 7 UFS applications with the global model providing all of the information in the green boxes on the right for medium range and subseasonal application, marine and cryosphere and seasonal. The regional models providing the application for hurricane and short range regional and regional atmospheric composition. And then, as I mentioned, in the future, building a UFS capable framework, using the UFS framework to build capability for these other applications. So I'm going to drill down on a couple of these and just show you what we've been up to for the last 3 years working on these various applications. This is a zoomed in view of that diagram you've seen. I don't know if anybody kept track, but last year when we had this meeting, I think this the funnel diagram was shown 27 times. Is that right? So, anyway, so I get to show it sort of first today, but we're really zooming in towards the bottom of the funnel, what Dorothy would call the higher readiness level work and development work. And you see that green triangle in the middle is the project I've been referring to, the UFS Research to Operations project. It's linked up with the broader UFS community towards the top, and it's also linked up with EPIC, which is providing support both for infrastructure within our project and support for the broader community as well. And you see UFS R2O is interfacing with that last step before the transition to operations at Weather Service. We're talking about the state of the science of UFS, and for our purposes, the state of the science is really the key element of why we're doing all of this. We want to have a more rigorously, scientifically based capability to do forecast. And in order to do that, we're bringing in community expertise, community intellectual resources from not only other NOAA laboratories, but also the cooperative institutes and universities doing NOAA-funded research as well. And in order to identify and prioritize what we needed to do in that science realm, we ask people what are the things that are keeping them up at night in terms of science issues. And here is a very compact list. Each one of these expands into a multi-page document about what we really need to be able to do. But you can see probably some of your favorite pet peeves: reducing the coupled model biases at the longer time range, improving the representation of some of the key modes of variability, notably the Madden-Julian oscillation for tropical convection, optimally combining observations of the Earth system and our model forecasts using an advanced data assimilation system. You heard about JEDI and building towards an Earth system, coupled Earth system data assimilation capability. Developing a convection-allowing ensemble forecast capability to give us short-range predictions for both severe weather in CONUS and hurricanes. Improving initialization at all time scales, from all spatial scales from convective to global, and all time scales going from short range on out to seasonal, and improving our observation advances in data assimilation algorithms. And finally, improving our quantification of model uncertainty using ensembles. So this is really one of the ones that came out in all of our surveys, and all the thinking was we want to be ensembling across all of our time scales going forward. So this was the project structure, and when we started the project 3 years ago, we did not have this structure. We had a very hierarchical structure with modeling on the top and infrastructure feeding in from the bottom, and we realized that we were being in some ways duplicative, that we had different infrastructure activities going on for different modeling applications, and that was sort of the antithesis of unification. So we reorganized the project in year 2 to have this structure. And what you see are the blue bars going across the page. They're blue on this screen, and they're sort of purplish on that screen. So whatever color you're seeing, the horizontal bars are our application teams. So we have our application team for medium range weather and subseasonal to seasonal. We have our application team for short range weather and convective allowing modeling. We have our application team for hurricane integrated applications. And then you see the vertical bars that are maybe orange or maybe brown or maybe some other color if you're online, that run vertically. These are our cross-cutting development teams. So we're developing, and if I work from the middle out, you see we have atmospheric physics and dynamics at the center, as well as data assimilation, reanalysis, and reforecast. Those are core infrastructure requirements for all 3 applications. And as we move out to the sides, these are also core development and infrastructure activities. Marine components, looking at ocean and sea ice in particular, and ocean waves. Atmospheric composition, thinking about dust and aerosols and interactions with radiation. Modeling infrastructure, which is really an EPIC's domain, thinking about how best to build model components and make them interact with each other seamlessly. And finally, our verification and post-processing infrastructure, thinking about how do we manage all of the enormous load of data that's coming out of our forecast models and our R&D activities. I'm going to report on the 3 applications primarily, and I'm going to say a little bit about our cross-cutting development teams. You're going to hear much more about that through the week in other presentations and in the poster sessions. And I mentioned I was going to give a shout out to all the people who helped develop the slides for this presentation. You can see all of their names are listed there. We have 2 co-chairs or 2 co-leads for each of the application teams, and we have co-leads for each of the cross-cutting development teams. And really, that's where the rubber hits the road. That's where the real work is being done. I will say, just for myself, I'm not speaking for Jeff and VJ, but just for myself, I'm just the eye candy. I got a couple of laughs that time. I mean, come on. Okay. So first, so this is the 4th time you heard somebody taking credit for the transition operations of the Hurricane Analysis and Forecast System version 1. The saying is that success has many mothers and failure is an orphan. So we're also going to take credit for HAPS v1 implemented into operations this summer. This was, as you saw on the previous slide, this was one of the core foci of the Research to Operations project, and has been, as you've heard, a tremendous success, being as good or better than HWRF and HMON in practically every metric that we look at. And we're very, very excited about the fact that this has made the transition to operations as well. These are just drilling into some of the application team's achievements over the past 3 years. As I mentioned, they've developed a coupled forecast system, which is built on the atmospheric component that has the FV3 die core and the ocean component, which is HICOM. You will see in a later slide how we're going to go forward from that. They finalized 2 configurations, the halves A and the halves B, and you saw performance numbers for those in a couple of the previous talks, and I'm not going to go into that. Both configurations, halves A and halves B, have demonstrated significant improvements in both track and intensity forecasts. And we see that this was based on about 2,500 cycles in retrospective forecasts. So a tremendous amount of testing and evaluation went into this development. Moving on to our short-range weather and convective allowing modeling activity. This is really the eye candy, right? So here's a smoke forecast generated from RUFUS, the Rapid Refresh Forecast System. Rapid Refresh Forecast System is our next generation regional high-resolution model. It's also being used and we're also developing the 3D real-time mesoscale analysis to support the National Digital Forecast Database. This is what you're seeing here in the picture is from the 3-kilometer CONUS, 3-kilometer contiguous U.S. forecast of smoke from the 26th of June. And of course, you can see the Canadian wildfires and the advection of smoke over the eastern seaboard. In terms of achievements that have been made by our application team, I put here at the top, this was kind of down in the weeds at some point, but I put at the top, bringing together regional and numerical weather prediction development teams from across NOAA and academia. This is really one of the success stories of the UFS and the UFS R2O project is tremendous teamwork going on right across between Weather Service, OAR labs, cooperative institutes, and NOAA-funded university researchers, all working on the same code, all working on getting the RRFS up to speed. This includes a hybrid ensemble variational assimilation capability with 30 members, and stochastic and multiphysics ensembles as well. We're running 15-minute, 2.5 to 1.25 kilometer analysis system, which I mentioned is supporting the National Digital Forecast Database. And the first versions of RUFUS and 3D RTMA are expected to be implemented in FY25. So hopefully in the next meeting or the one after, we will be talking about another success story of transition to operations. Oh, and I forgot to mention, let's see, let me go back. Here we are. I forgot to mention that RRFS was used in the spring testbed experiment this year and performed quite well. Moving out to the global scale for medium range weather and the subseasonal to seasonal application, the main thing here is the development of a 6-way coupled global system. It has components for the atmosphere, FV3 die core, and CCPP physics, and I'll mention that in a minute. MOM6 for the ocean component, SICE6 for the sea ice component, WaveWatch 3 for the wave component, surface ocean waves component, NOAA MP for the land surface component, and GoCart for the aerosols component. Just drilling down to some of those achievements, we've been doing pre-operational testing in a very large series of prototype experiments with the global coupled system for implementation in the global ensemble forecast system in FY26 and also the high-res global forecast system version 17. The next-gen DA system, the data assimilation system based on JET-A, is in initial testing right now. We have a weekly coupled capability based on JET-I for GFSV17. There's a new atmospheric physics package that I'll talk about. I have more bullets on that in a slide or two. And an ensemble system with stochastic physics in the atmosphere, the land, and the ocean. We are in the process of generating reanalyses using a replay methodology for GEFSV13. We're testing interactive aerosols using the GoCart model, and we have a prototype data. All of the prototype runs that have been done with this global system output data is available in the cloud, so people can analyze the prototype runs to their heart's content. I'm going to mention just a couple of the cross-cutting development teams because they are making tremendous progress in all of the teams, but we'll just mention a couple of them because these really get at the heart of the scientific development that's going on. Our data assimilation, reanalysis, and reforecast team has been accelerating JEDI-based data assimilation in the non-atmospheric components of the coupled system, including doing capability for snow assimilation, coupled ocean sea ice assimilation, and initial capabilities for assimilating atmospheric composition. A 40-year reanalysis, this was reported on last year, but this 40-year prototype marine reanalysis has been generated with JEDI. There's an initial demonstration of the weekly coupled data assimilation package, and I think there are presentations this week on that. There's the capability to do all-sky microwave data assimilation, and we're getting prepared for the fully coupled, the strongly coupled reanalysis. This is just a preliminary result from the weekly coupled data assimilation, and what you can see, if you just look at the diagram on the right, you can see many more observations are passing the quality control test, and we're getting much smaller observation minus background errors. So we're making a tremendous improvement in the data assimilation capability by using marine information in the atmospheric and using atmospheric in the marine data assimilation. Moving on to our modeling infrastructure development team. This is a couple of different subgroups. One of those is our Common Community Physics Package team, have designed and developed and implemented the Common Community Physics Package for UFS and community models. This is the operational transition of CCPP has already taken place in HAFS V1. CCPP, it's very hard to say that, Legia. We have to come up with a better way. I don't know. Anyway, CCPP version 6 public release was out last June. And a lot of details there I'm not going to go into, but basically the CCPP is there, available for you to test, including in single column model capability. I wanted to dwell on this for just a second. CCPP, a common physics package for use in global and regional applications. So here we have a centralized authoritative code repository, so all the code is in one place. So this simplifies that quilt and also simplifies on the research side. We have runtime configuration of the physics suites and physics package through the framework. It provides an agile test bed and workflows, particularly through the single column model. It enables, I'm going to point at Mike Eck, it enables hierarchical system development and capability. Just because I know you're going to ask that question in a minute, so I'm just teeing it up for you, Mike. And yeah, and I already mentioned about the single column model capability. The other side of our modeling infrastructure development team is the Earth System Modeling Framework, which is sort of the underlying software framework for coupling model components. Just recently came out with the Earth System Model Executable Layer, which simplifies standing up and maintaining systems that are based on NUOPSI. You can ask me at the coffee break what NUOPSI stands for. We also, you heard about SPAC Stack. I think that was in Dorothy's presentation. I was very impressed that you brought up SPAC Stack, so that's good. This is a new build of ESMF that's supporting UFS. ESFM managed threading for UFS applications. So thinking about doing parallel operations either inside the core, inside the node or going across nodes. And then the exchange grid implementation that simplify or makes more robust and rigorous the exchange of information between different grids from different component models. Our atmospheric physics and dynamics development team has been working on unified processes across scale. We have had scale-aware physics in the past, but now we're bringing together unified capability across scales, including the scale-aware convective parameterization, the two-moment microphysics. These are all things that we have had, enhanced gravity wave physics, improved PBL and convection, and the NOAA MP. That's the latest version of the land surface model. We also have enhanced tropical variability prediction. So this is in tests with the global model. And finally, we've attained world-class skill in shallow convection cloud prediction using RRFS. So there will be details about all of these things, and the people who are the actual experts on that are here in the room, so I will defer to them when the questions get really hard. And finally, our atmospheric composition development team has been hard at work implementing GoCart within the UFS framework. We now have UFS aerosol, which is a prognostic aerosol component in the six-way global coupled system, provides a strong foundation for the next generation air quality forecasting. Also has the capability to do fire weather. So we heard just earlier there's going to be a new emphasis on fire weather. So we have that capability coming along. Both direct and indirect aerosol effects are included. And we have the capability to look at biomass burning, at least in terms of climatological inputs. So moving on to where we are now. So just earlier this month, we finished the third year of the project, which we've been calling Phase 1. It was a 3-year project. We just started Phase 2 on July 1st. And here, the idea is to support a number of upcoming operational transitions. So we expect to transition the next version of the hurricane model. Thank you. We'll be transitioning Rufus version 1 and the 3D RTMA version 1. GFS version 17 and beyond, I already mentioned, and GEFS version 13 and beyond, I also already mentioned. We'll be prioritizing the transition of externally funded projects. So this is, you heard that there are new funding opportunities coming from both OAR and Weather Service. So we'll be working hard to find ways of transitioning those into the R2O project. We'll be depending upon forecaster feedback for as these things are being both tested developmentally and transitioning operations. We're relying on forecasters to tell us what's working and, importantly, what's not working. And there's actually a thread going on right now about the surface temperature bias that we're seeing in the regional model. And finally, integrating UFS R2O with the new seasonal forecast application team that was mentioned by Dorothy. We are anticipating in each of our application teams substantial improvement in Phase 2. On the global model, we're expecting to have a fully coupled extended reanalysis and reforecast set. For the regional model, we will be addressing the long-standing convective storm structure issues, and you'll be hearing more about that later in the week, and also transitioning to using JEDI for the data simulation. For the HAFs, we are developing multiple nest capability, as well as transitioning to the JEDI for data simulation, and importantly, building ensembles with stochastic physics. And finally, looking forward to integrating new science and infrastructure from the development teams into all three of our major applications. I'm out of time. I'm kind of running short on time, so I'm going to leave this up here for just a second, and I apologize to all those of you who worked hard to put these slides together. But you can see a number of the things that are coming forward from our development teams in Phase 2. Very, very exciting developments, both in terms of physics and atmospheric composition. Also, data simulation, I mentioned the transition to JEDI, but also looking for coupled assimilation across the six-way coupled system. Modeling infrastructure in both CCPP and ESMF are expecting to deliver new capabilities, both for sort of computational performance as well as more science infusion. And just to give you a teaser, this is work that the seasonal forecast application team is putting together, testing the prototype 8 version of UFS. And I'm sorry, I don't really have time to tell you in detail what's in this figure. I wanted to get to the last two slides. So where do we stand? So UFS is unique in the world right now because we have the capabilities to do operationally relevant research for prediction science. And we have a long way to go to actually make that happen, as you've been hearing, both in terms of the infrastructure to support development, but also in terms of the transition to operations. UFS now has end-to-end capabilities, including data simulation, that are lacking if you go to some of the open development systems. So this is the opportunity to do real forecast research and development. thinking about going from OBS to forecast. And finally, this is really the bugaboo that we have. And our capabilities are lagging behind other operational systems, notably European Center and the unified model from Met Office. So we still have a long way to go. What are we planning to do to try to realize that vision? Well, there was a report came out, I guess it was a year and a half ago or so, the priorities in weather research. It was referred to earlier as the Power Report. One of the big recommendations there is more computing resources. This has been a limiting factor for the Research to Operations project, and clearly is something that we need. If somebody asks you what you need, you say more. So we need more computing resources. We're going to be doing operational transitions for all the applications and the transition to a JEDI-based data assimilation. We need to advance the UFS as an Earth system model. So it's been highly focused on the atmosphere, but we need to get that Power Report recommendation to do Earth system model forecasting. We need to reimagine the production suite. We've already moved from the quilt to a vision for how the quilt should look. We need to reimagine that in terms of how we do cadence of implementations and how we think about doing a more effective way of transitioning research to operations. We need portable systems and workflow. The research community is crying out for a workflow to be able to run the operational system or research and development system, including data in, data out, analysis and testing. And finally, Dorothy brought this up, we need a governance plan that's finalized. We need a community-driven, well-defined rules of engagement. This is the stages and gates, but it's more than that. We need a well-defined governance and also, very importantly, accountability. So thanks very much. I think that's the last one.
Thank you. For those of you who want to take a closer look at the slides, I believe they're available on the event website. So do feel free to do that, and also seek out Jim and his colleagues to discuss anything that that struck your fancy and that you want to hear more about, or share your ideas about. Thank you. Next, we'll hear from Dr. Sarah Liu about her experience using the UFS as a teaching and research tool. Dr. Liu comes to us from the University at Albany, which is part of the State University of New York system. She also works at the Joint Center for Satellite Data Assimilation. Her research focuses on quantifying the distributions of tropospheric aerosols and improving aerosol forecasts through the assimilation of satellite and in situ aerosol observations. Please welcome Dr. Sarah Liu.
Thanks for the introduction. So before I joined Albany, I actually worked for NOAA and EMC, so I saw many of my former colleagues, and actually my former boss here as well. And so I was asked to talk about using UFS as a teaching and research tool. So I will outline this talk before I answer why I use UFS, I will talk about some background based on my previous experience working for NOAA. So it's on the operational side. Then I will talk about how the research community can benefit from those community-based development. And because UFS is not the only and first community model, but by working with that, we do see the great potential to, which I will address. Then I will come to why UFS. So we're supposed to do this.
Move forward.
Okay.
There you go.
All right. So the background is really about my previous experience running NOAA global forecast system. And no, wrong side. And then I was tasked to implement NOAA land surface model and then NASA's gold card into the global forecast system 15, 20 years ago. And then what was my approach then? So what I did is actually I identify those colleagues who really know the code. I went to the cubicle. I take a notebook, I take a pen. So I told to them, say what I need to do. So those experts told me, oh, here's my code, this is my name list, this is run script, this is my results. So then I try my best, write down everything, and try to reproduce. And this process, it's not easy because most of the time I don't reproduce because I may not explain myself carefully, and then my colleague may forget to tell me some name lists there. So this is really labor-intensive process. So I talk about this from the 5 aspects, from the code management, from the workflow, documentation, and the effort to reproduce other people's experiment, then the effort to spin out a new person. So at that time, version control was actually introduced years later. So at the beginning, really, sometimes you do code development and your colleague have some in parallel experiment development, and it's not easy to actually synchronize everything. And then internal workflow, it can be quite complicated, and there's a layer-less configuration. So it's a lot of labor just able to really understand the code and the workflow and configuration. And at that time, documentation, is often either not exist or is out of date. So it's really, so the effort to reproduce your colleague's experiment is involve a lot of effort. It's a kind of try and error. It's like guessing game. So you try, and then if something not working right, you go back to your colleague and then try to clarify why am I not seeing the same results yours, even we run the same platform. So by seeing this, you can see it's actually quite a extensive effort to spin a new person. And that time, after I do my postdoc, so it's not like, even not, so you can see if you want to spin out a graduate student or postdoc, it's probably even more effort there. So that was before the UFS, before NOAA take on the community-based approach. So now I'm going to talk about the community-based development, and this is really from the perspective from the one, my experience, the experience from my group. So there's maybe other university faculty, they're much more advanced about running UFS, whatever. So this is really, I just want to share our experience, my group's experience learning and running UFS. So again, I will talk about all this same topic I mentioned in the previous section, but I will talk about specific to a platform here, which in my viewpoint still remain quite a challenge for the university to run UFS. So the UFS, as previous talk, as NOAA shift to community-based development, UFS is comprehensive community-based, develop Earth modeling system and design a sports research tool, and then also for NOAA's operational forecast. So this is a unified system with shared science component, which previous speaker just mentioned, and then also share the software infrastructure. So given this, and then internal code manager, so now there's a community repository, and then you can see quite clear how the development process evolved. So we can, with the GitHub, we can see that there's different model workflow we can check out. And then couple days ago, we have telecom with our NOAA collaborator and discuss, we want to configure UFS for specific aerosol experiment. And at that point, we have some experience running certain microphysics scheme, and we want to try the Thompson scheme, which, we was told is aerosol wear. And we want to know whether specific support certain kind of aerosol. And that time, we was able to just go to the community code repository to see exactly how the model is configured in the CCP physics suite. So those are really enable us to keep up to date what's going on. And this probably not operational code, but at least we get a flavor about, later I will talk about operational suite, but this one enables us to know all the exciting research going on in the UFS. And then for the workflow, as I mentioned before, you talk about the workflow, it can be quite complicated, internal run script and set up configuration. But now there's a unified workflow tool to use, and then with various UFS application. So this was, under this unified workflow will enable us to really build and run the UFS without really too much the guessing game I mentioned a long time ago when I first ran the GFS back in the NSEP. So, and then my student, my postdoc was able to able to run following those documentation about workflow quick start. But then the key issue we're facing is actually on platform. Working on the supported platform is actually fairly straightforward. So there's no issue at all. And then, the cloud computing sense, I think presents very exciting opportunity. And then the portable, given the container, it's much easier to port to different platform. Those are all present very exciting opportunity. But at least for my center, I talked to different colleagues. We right now at this point, maybe other universities have more resources, but for us, cloud computing seems still quite challenging. The issue is really just we are quite nervous about the cost, potential cost. So we get the impression that that's not something we can afford. So if we cannot afford cloud computing, if we don't have a supporting platform, so for us to teach UFS in the classroom, we will need to port UFS in our own cluster, and which is an unsupported platform. And this turned out to be really challenging because, for example, when we try to port the Ricotta-based workflow, and we have library is out of date. So we won't be able to install our library ourselves. We need to send a ticket help desk for them to do that. So those kind of process does take time. So I think for the university to really actively use UFS as a teaching or research tool, how to make those, and then I'm sure I'm probably not the only faculty have limited computer resource, so but then to make the teaching easier, we need to put on our relatively small cluster. So the support to enable us to run UFS at those university platform will be, I think, is probably at least, I would think that's probably the primary challenge, in my opinion. And in terms of documentation, there's a lot of documentation online, and then the science-based documentation is very, very helpful, and then the documentation is very, very informative. And however, the struggle we have is really a lot of information, and then sometimes we struggle to find the key information, and sometimes we run into some document actually it's out of date, and so I guess. And then for us, we identify, we may have, when we go through a documentation, we have some kind of idea, say, well, I wish documentation tells this, tell us that. But at this point, it's not clear to us who we should talk to provide our feedback, to make the documentation even more user-friendly, yeah. And then, but up to now, we do find those documentation, it is very, very helpful. So we follow a user guide, we follow a tutorial. So my student, my postdoc was able to make a good progress in running UFS for their research. And so those are very helpful. But there's some little thing, I think a lot of effort here create very nice virtual development environment for the university to engage in. But some piece probably still need to be tweaked to make it really able to really support the research community. And then in terms of experiment, there's some use case enable us to run the out-of-box case, which is very, very nice to get started. And then, as I mentioned earlier, I think the container cloud is actually present very nice opportunity. But in the short term, if we don't solve at least for cloud computing, at least for my university, if we don't solve the resource issue, that option is really not really available to us right now. So they're back to the old-fashioned way that, somehow configure our own local cluster able to run UFS. Then in terms of spin up, as a university, one of the primary goals is to really train young scientists and later prepare them for the workforce. So we tried the graduate student test, which I guess now they call the usability test. So I would kind of showcase my postdoc's study, and that was actually spin-up based on the usability test. And we also had another student recently take the code fest, which was supported by EPIC. And the student will share his experience this Friday in the Friday section, making the UFS cool. This section about his experience running UFS through the spin ice through the cold fast. So, and the online resource, so far as what we see is there's abundant online resource there available to us, but sometimes the way they organize is not necessarily easy to find, but we recognize it's there and it's helpful, and although sometimes we struggle to find what we're looking for. And then we do appreciate very much the support from EPIC team. So let me showcase my postdocs work just to show how we actually benefit the UFS community-based co-development. So in the first annual UFS workshop, and then Dustin presented his work using UFS to looking at aerosol impact on the landfall Harvey. And this work is collaboration between the Albany and the EMC scientists. So the purposes of this study is really examine how the aerosol cloud feedback affect the forecasting Hurricane Harvey, and the modeling tool used is UFS. And then, so the way we configure model physics is the radiation. We use RTNG, so that means aerosol attenuation will affect the radiation. Radiation will consider aerosol attenuation. So at that time, the default is opaque climatology. So we work with EMC scientists to implement the option to including aerosol to attenuation to be determined by gold cup aerosol. At that time, the EMC implementation is to use 10 years plus mirror-2 climatology. And then for the microphysics, the default is to CCN nucleation, and the ion activation is determined by temperature, so it's not aerosol aware. So the EMC scientists also implement the aerosol aware in the Morrison scheme. And so the CCN, we follow, this is actually been our previous collaboration with NASA, so the CCN nucleation ion activation is actually determined by aerosol. So it's really, we check out the code using default is aerosol aware using opaque climatology, and microphysics is not aerosol aware. But through working with ENC, we are able to bring the more neuroscience element in the experiment. So the experiment is very simple. We still consider aerosol direct effect, so that means we use RTNG, and we do a quick 10 days forecast, and then initial condition is found known as a final analysis field. And our control run is CCNIN activation is actually temperature dependent, but not aerosol aware. And in the aerosol run, the CCNIN was determined by mirror-2 climatology. So it's really just, this just shows the model sensitivity. So the experiment here on your right side is the intensity, on the left side is the track. So, and then the blue color is a control run, and red color is aerosol run. So when we compare with, although the model still, even both model runs still have some disagreement with observation, but when we consider aerosol aware in the microphysics, and then we do have better track and also as intensity as well. So the summary is really, we find the results quite encouraging. In terms of, that's why we care about it. We want to learn the new science we want to learn the new science, and the UFS is the tool we use. But the primary thing I like to share is really our experience learning and running UFS. Really, at that time we took the student and postdoc took a first UFS release and graduate student test, and a couple months later took another one. It's weighted only UFS. And then through discussion with a NOAA scientist, and we upgraded physics 2 months later in April. So we upgraded the physics configuration to the newer physics, I guess at that time it's version 6 beta version. And then we updated the source code to include aerosol radiation cloud feedback. So then months later, we were able to run the experiment, and then through the postdoc hard work, 2 months later, we can show the result of the first UFS annual meeting. So, but this timeline is not possible if you don't have the repository, and then if you don't have the easy workflow for us to adapt. So I like to share the key lesson we really learned is really, we find those tests, graduate student tests, now we call it usability tests, even the code fest. It's really effective way to spin out our students and postdoc. And the second is, code repository allow us to really keep the code up to date. But I like to emphasize my third point is really, I think the whole UFS through the unified workflow, through the community repository, that create a very nice virtual community development environment. That's wonderful. But I think, at the end of the day, for the project to be productive, I think the one key element is really we reach out to EMC, NOVA scientists, and we have a lot of interaction. So you can advance a lot of technology, you could have wonderful cloud environment computing or code repository, but at the end of the day, the in-person or, well, during COVID, will be virtual interaction, those are still remain very, very important for the very productive, the interaction between the, UFS between the with the enterprise, and then I still think the interactions remain the primary thing to make things happening. So I guess, so this section is why UFS and then why, so my short answer is really why not, really. It's really, for me, it's no-brainer because, for us, even, we share students say, well, that's what NOAA's model they're using. That sounds very exciting. Students can get firsthand experience about those state-of-art science. And then, so really why we use UFS as a teaching and research tool, there's a lot of advantages. The online resource and user support to spin our students and postdoc, and that makes things much easier compared to 15, 20 years old when I work for NOAA. And then the use case, particularly those well-documented one, is a very nice template for us to get started. And then the code repository provide a consistent code base for us to develop and run tests. So all of these are really create a very nice environment for the research community, universities community to engage in the development. And our experience with this, a lot of little things still need to be tweaked to really, so I think it's really, I will not say it's there, but it's really getting close. So the advantage really from the O2R aspect, that enable us to really contribute. Potentially we can, when I first say, when we can check out the code, means enable us to really access the open source prediction model suite. So a lot of our work benefit a lot from those O2R. But then another side of the story is, enable us to do a very interesting research, but if our code was committed to the repository and tested by NOAA, and then we could potentially contribute to the operational outcome, and that's a very exciting element, the engage this development. So this is our tool aspect of this. But up to now, so far it's not clear to us how do we contribute to the repository, but which I think in this workshop, I'm sure this will be all figured out in other presentation, I guess. So I'd like to emphasize this really experience from my own group. So there's maybe a lot of other faculty figure out where to find the right documentation, figure out how to do cloud computing or all this, but I can only share what I know here. So, and then the last thing I think that's very exciting is you can see, as previous speaker mentioned, very exciting, very broad science element in the system. And you talk about not just atmosphere, your ocean, CS, and my favorite will be aerosol. So you have a lot of very exciting element there, and not just model, you talk about ensemble and DA. So, and then this will create the environment and enable our young scientists to engage in the development in a very broad, different area. So I guess I'd like to endorse the last slide, say, well, where to focus the support. And I can see for students, postdoc in my group, where some students interested to do DA, And we have students, actually want to figure out how to use our own local network measurement. We have, in the New York State, we have flux measurement. We want to know how to use that to verify model. And we also have students interested in really do code development. But then some other students really just run the model for air quality application. So for the 5 items you list, I can see university, at least my group or my colleague will be interested in engage all of this. So I guess that's I guess that's all I have, and I welcome the comment or suggestion. This is why my former colleague.
All right. Hey, Sarah, great presentation. Number one, it's important to note, since you do have that kind of insider baseball, inside connection with EMC, I think that's an important aspect of the story. But when you compare that to, say, someone that this is their first time attending a UFS type of event, what would you recommend, and where can we, focus some of our energy? Because I saw that almost basically February 2020 to July with the student. Where can we continue to focus our energy in order to kind of speed up that process? Because not everybody is going to have a person inside.
So I think that would be, when we go through a browser, a lot of website, the online documentation, and it's a lot of information, and sometimes we struggle to find things we looking for. So, and then even with some ENC connection, I'm still struggling. So I can envision for the university just have very exciting to work on UFS. I can see can easily get lost. So I think probably a nice entry point, instead to jump into a lot of technical information, a little bit more broader but up-to-date documentation. So for the university faculty, when we see, we can envision, I can see my student work on this, work on that, and we know it's up to date, and then before you jump to a lot of technical detail. So, yeah.
Thank you for your presentation. It's really useful for us to hear, where you're getting stuck, which is looks like in a lot of places. But I wanted to kind of try to connect your experience with what Jim Kinter mentioned in terms of an interest in working with basically the model that's in operations, I guess. Let's take the one that's in operations and work with it and see where we can find its flaws. Is that more where you would like to be working, or it sounds like you're also interested in actually developing the model that's not yet final?
I think both, because for us, you work with students, they have different background, different interests. So you have some of the students really, one of my students just want to do air quality and test on COVID impact. So in that sense, his efforts to compile emission, so we are really just hoping to adapt IFS for the application. So those students were more like a user, but then you have some other students very interested in those detailed science, and those will be a developer. So I guess as universities, member the enterprise, and the university come with a lot of students with different background, different interests. So it is very broad. That's all I can see.
That's what I'm hearing, is you want to do both. But again, I think if you want well-documented code and you want all the things that you want, we need to start somewhere. So
that's right.
Yeah.
And so this I mentioned, we find a lot of little things here there that can be solved. But for us, we have no idea how to contribute a code repository, and we don't even know how to provide our feedback. Say, well, this documentation is out of date. It can be as simple as this, yeah. So, thanks.
I have a couple of questions. One is whether whether you think there are enough mechanisms for you to provide feedback or for university folks to provide feedback about where you see these gaps. And I know you provide a couple examples here in this talk, but in a more systematic way, like Jillian standing there, she does a lot of documentation. I'm wondering if that's connecting. Like, does she know where these gaps that you were
That's
talking
right.
about are? So if there is no mechanism, then we need to establish those. And the second question is, I think it would be really interesting for someone, I don't know who, to develop, teaching curriculum with the UFS so that professors like yourself could pick it up and use it more easily in the classroom. And do you think that's a good idea?
So, Lydia, I guess that's why I registered this meeting, because I want to learn how to provide my feedback. And then for the teaching tool, I think the one thing is really more guidance about how we configure our university cluster. So student doesn't need to go through, we don't want a student when they check out code, everybody send IT help desk ticket to install certain library. So I guess platform will be the primary thing to solve, in my experience. But I can only speak my own group, so. Thank you.
Thank you. Thank you, Sarah, for your feedback. That's very helpful to my work in particular. Also, anyone who has similar questions, I would love to talk with you at the break, because there's been some changes to user support lately that hopefully will solve some of these problems. Next, I have the pleasure of presenting Dr. Tamara Battle. She is the...
Not doctor.
Oh, I'm sorry. I'm so sorry.
Not yet.
Oh, not yet. Okay. Oh, she's working on it. Okay. So next we'll hear from Tamara Battle, who is the Policy and Partnerships Lead for NOAA's Weather Program Office. She oversees various aspects of the Weather Research and Forecasting Innovation Act of 2017, as well as other weather policy topics for both WPO and NOAA research. Currently, she's focused on developing a partnership strategy and improving stakeholder engagement and student involvement in NOAA programs, which dovetails nicely with the fact that one of EPIC's strategic investment areas is community engagement. So I look forward to this.
Okay, thank you. Hi, good afternoon. So I have the pleasure of having the final presentation before our first break. So everybody just hold on. We're almost there. I know coffee is calling, so let's see what we can do about that. So as Jillian mentioned, I'm Tamara Battle. I'm the Policy and Partnerships Lead within NOAA's Weather Program Office, which is a relatively new position, only about a year and a half old. But I love the fact that WPO thought that this was a really important area to have a focus and lead in, to really try to tackle some of these issues across the weather enterprise. So I'm not here to solve the problem. That is almost impossible. We won't solve the problem today or even this week, but thought that I would be able to share a few ideas and strategies to create partnerships and expand our approach to engagement. You probably see Spider-Man hanging off of the Y in community. There's a reason for that, so let's take a look. So we've used this information before, but NOAA's weather research really spans from observations and monitoring, watches and warning, to short and medium range forecasts and subseasonal and seasonal outlooks. And as Dr. Morgan mentioned earlier today, modeling and forecast applications is not just the only pieces that we focus on. Observations is important, as well as products and communication. And as you can see, that value chain that's on the right-hand side, all of those flow into each other. So it's not a linear process, but they all flow back and forth into each other. So weather research really spans this forecast value chain. And so for us, and we like to use this diagram in WPO, well, we have NOAA at the center, but strategic partnerships are the bedrock underpinning weather research at NOAA, as well across the weather enterprise. So, of course, we facilitate and help to work on research and development through partnerships across the weather enterprise, and shepherd through projects through the R2O process, from research to transition to operations. And of course, the UFS is significant with that, but we want to talk a little bit more about partnerships and how we can expand those connections. And so when I started thinking about this, I thought it was important to set the table. We use the term next generation workforce a lot, but really it's not the next generation workforce. It's the now generation workforce. These students are here now and they're ready to engage with us now. So it's not about 10 or 20 years down the line. We need to start engaging the now workforce. So really expanding the search for diverse individuals to really look at the now generation workforce. Also, we need to think about insights into inclusion, learning and addressing the barriers across the weather enterprise. And so what does that mean? What are the things that are in the way from those individuals or students or postdocs or at other academic institutions that are not traditional institutions that are in the way of really accessing the UFS as the tool that it is? We also need innovative trailblazers. We need to stimulate creative and thinking and nurturing innovative ideas. Oh, that word is used constantly at NOAA, innovation. It's used sometimes ad nauseum. But it's exactly what we need. We cannot continue to do work the way that we used to do it. We have to start thinking outside of the box. So we really need trailblazers that can think differently, that are willing to think outside of the box, and then we've got to be willing to embrace that. And then also what I like to call champions for change. So Dr. Spinrad has mentioned on many occasions that NOAA, for example, is an agency that is leading the way, but it's also risk adverse. And so we need to be able to be willing to take more risks, not only at NOAA, but again, across the weather enterprise and how we approach some of these problems and challenges that we've had. So we need champions for change to embrace new approaches to old challenges. And I like this quote from Stephen Covey, which says, "Strength lies in differences, not similarities. The more diverse and inclusive we can make our community, the more ideas we foster, the more innovation we welcome, the more challenges we can face and begin to solve problems together." So when I started thinking about this, and you'll see in the agenda, it's kind of broken down into three pieces. The first part was the need for partnerships, and that comes down to inclusion. And so when I thought about this, I was like, well, I'm not a modeler. Modeling is not my ministry. It's not my forte, but it is important. And so I was, how am I going to talk about partnerships and kind of marry this to the UFS? And forgive me for this, but I thought of Spider-Man, okay? So Spider-Man is a superhero that many of us are familiar with. There are many versions of Peter Parker that we've seen. He has his nemesis in James Jameson, who oftentimes is not sure if he's actually a hero or a villain, which kind of sometimes made me think about UFS because is it here to save the day or is it a problem? I'm not really sure, but what was interesting to me was in 2018, we ended up with a new version of Spider-Man, Miles Morales. And this was the first time that in movie form that Spider-Man came out as a half Black, half Latino character. Here's where this wraps into inclusion. What was fascinating to me was the impact that it had on young children. In particular, I have a nephew who in 2018, my friends and I, we had a Halloween party, and he was like, I have to be Spider-Man, but not the Peter Parker version, the Miles Morales version. And I was like, okay, that sounds cool. And then the party comes, and 3 other Miles Morales Spider-Men show up. All of the boys showed up as Miles Morales version of Spider-Man. They were excited to see themselves included. And they saw themselves at that point as a superhero that could help solve problems and save the day. So if we really want to tackle the unified forecast system, we're going to need diverse superheroes. So I want to talk a little bit about where we can maybe find some of those superheroes. And I want to have a conversation very quickly about NOAA Cooperative Institutes versus CSEs, because I think that this is an untapped resource. So cooperative institutes, and the earliest that I could find was was established in 1967, is identified as a NOAA-supported non-federal academic and or nonprofit institution that has an established, outstanding research program in one or more areas relevant to NOAA's mission. Cooperative science centers, which are also supported by NOAA, and the first one since 2001, is a consortium of academic institutions led by an MSI, or minority serving institution, that have demonstrated education and research performance in NOAA mission sciences. So when we look at cooperative institutes, these are established, outstanding research programs, but cooperative science centers are identified as having demonstrated education and research performance. But that doesn't sound too dissimilar to me. They're both committed to the NOAA and the Weather Enterprise mission. In particular, and shameless plug, I am a result of two CSEs, or Cooperative Science Institutes, City College of New York, which is the lead of the CSE, and Howard University, which is the lead for the NCAS-M CSE. And so, and I think I'm pretty awesome. So there's some great products that come out of the Cooperative Science Centers, and I'm gonna shout out a couple of others because we have Dr. Chris Spells here, Dr. Aaron Pratt, Dr. Danae Carlis, all of whom are results of CSCs. But there are great resources that come out of the Cooperative Science Centers. For example, did you know that of the doctoral degrees that have been granted in the United States from 2003 to 2019, a majority of them for African American and Hispanics have come from the Cooperative Science Centers? And when I say that, I mean 54% of the doctoral degrees earned by African Americans in the atmospheric sciences have come through the Cooperative Science Centers. 21% of the atmospheric science degrees earned by Hispanics have come through the Cooperative Science Centers. And there are similar numbers for environmental sciences and marine sciences. So there is a wealth of information there, and there's a wealth of resources there, but oftentimes they're looked at as though they're in competition with one another. They shouldn't be. They should actually be, I hit the wrong button. They should actually be a partnership between the two. So let's think about how we can consider a strategy for leveraging not the NOAA CIs versus the CSCs, but the NOAA CIs and CSCs. So most of the cooperative science centers are co-located with NOAA labs or centers, which allows for optimal collaborative opportunities. And that's wonderful, but we also have several CSCs, minority serving institutions, historically Black colleges and universities, tribal colleges and universities, Hispanic serving institutions, partner institutions that are also located within close proximity of cooperative institutions and or NOAA facilities. And that creates an avenue for increased collaboration and support. So here's a strategy. Why not establish various CSCs or HBCUs or HSIs or MSIs as what I like to call UFS modeling centers of excellence? Why not? We have had a number of opportunities to collaborate with traditional universities, but many times the resources are not available at other institutions. So what do we mean by that? We've heard in a couple of presentations, in the previous presentation, cloud computing and HPC is already a struggle at academic institutions, even more so at minority serving institutions. But having those kinds of resources allows institutions to be able to get in on the ground floor of accessing the UFS instead of chasing behind the research and the opportunities. Many MSIs don't have the infrastructure that is needed or the access to resources, which oftentimes are left out of the loop of being able to access the UFS, okay? Also, we've been talking about infrastructure, but there's also a human infrastructure that we need to consider. At a lot of MSIs, faculty are required not only to teach, but also to write proposals. And then because there's a huge push for DEI initiatives, they're also required to mentor students to come up with DEI efforts at their institutions, and so on and so forth. And so sometimes the resources of just the human factor are limited at many of these institutions. And I'm sure that that's also mirrored at many traditional institutions. So how do we tackle that? And so again, by having HBCUs, HSIs, tribal colleges, and universities welcomed in at the ground level, on the ground floor, we can begin to really be more inclusive in how we tackle this particular project or problem. And one of the strategies is to maybe host workshops like this or workshops for UFS at those institutions. Oftentimes at workshops like this, you have one, maybe two faculty that are able to attend from minority serving institutions. But if an institution were available to host a UFS workshop, you now are welcoming them in on the ground floor. So strategies for partnership not only include inclusion, but also collaboration. I'm now going back to my Spider-Man theory. So if you don't recognize this character, this is Kingpin. The one thing that you will notice about him is he's huge. He's a very large villain, which I kind of think of as the Earth Systems community modeling situation. It's big. It's a big problem. It's a huge problem. There is no way for one superhero to be able to tackle it. Here's what I like about the new Spider-Man, because it now not only dealt with one Spider-Man, but in order to tackle this particular villain, they needed a collaboration of several superheroes. And each one, even though they were all Spider-Men, had their own unique talents that they brought to the table. Through collaboration, we have an opportunity to really reach out and consider different talents, skills, abilities to tackle this very huge problem. And so when we think about that and we're looking at partnerships, here's a snapshot. If you don't see your institution, that's deliberate, because there's no way to include all of the institutions. So this is just some of the federal agencies, some of the internal NOAA labs and centers, and a few others on the side. But this is just a snapshot of partners. But when we are thinking about how we look to find the next generation workforce, we have a lot of issues that we need to tackle. We've said that what we need is people that can be focused on data assimilation, on atmospheric physics, on the problems of machine learning and artificial intelligence, software engineers, atmospheric dynamics, air chemistry, verification and validation, systems architecture. And here's where we've been searching. We oftentimes have been looking at AMS, NCAR, and AGU. Great resources. Nothing wrong with that. But are those the only resources? Or could we perhaps expand that a little bit more? So here's a strategy. Expand the search grid and the criteria. We shouldn't only be looking at certain organizations or agencies for atmospheric scientists and oceanographers, because we have larger problems. Do I need to go back to the Kingpin slide? It's a big problem. And we need a diverse set of individuals with diverse thinking to tackle these issues. So we need to be looking all across different organizations to find the next generation workforce. So we need to be looking at SACNIS, the Society for Advancement of Chicanos and Hispanics and Native Americans in Science. We should be looking at American Society of Civil Engineers, or the National Society for Black Engineers, the National Association of Black Geoscientists, the Association for Computing Machinery. And so this image, I had the privilege of being able to attend the NSBE, the National Society of Black Engineers Conference earlier this year in March of 2023. And this was just a picture that I took from the audience during the opening session. Here was the cool part. NSBE 49 registered over 13,000 attendees that were all STEM majors. That was one conference that had over 13,000 registrants and attendees. And so this was actually the first time that NOAA had a presence at NSBE. We ended up with about 7 people that were able to go. And we held a session to talk about NOAA and our mission and environmental engineering and how we could welcome students in. Here was the coolest part. Most of the people that attended NSBE that were in the space of, hey, we want to hire you and you can make a lot of money. The students that attended our session, and I will not lie, it was not a lot, but what was refreshing was that they said, this was the one session where someone talked to us about a mission and not just about the money that we can make. And there are students out there that want to know how can they make a difference. Not just how much money they're gonna make, but how can they make a difference? And so they were interested in hearing our message and in hearing about what they could do to be part of the solution. So if one conference had over 13,000 attendees, what could some of these other conferences have that we tap into to start looking at other resources? And then expanding the community. This is going to take innovation, okay? And so when I started thinking about this, the strategy for this is just to simply level the playing field, okay? And so there's now the new Spider-Man that's out. I will not give out any spoiler alerts, but there's a whole lot more Spider-Man in this one. And so when we are thinking about how to level the playing field, when we're thinking about the next generation workforce or the now generation workforce, we've got to think about how they consume information and how they get connected to the mission. So we've got to start thinking ourselves a little bit more outside the box. There's supposed to be a presentation on Friday about how to make the UFS cool. We need that presentation. We've got to talk about that, okay? So using social media and virtual connections to meet the community where they are, reaching out directly to many of these institutions for ground level engagement, integrate and mentor new talent in the workforce, and a lot earlier in the process. I'm gonna push back on the previous presentation because there was a slide in there where it was mentioned about graduate students and postdocs. We have 3 students right now that are WPO interns that are undergraduate students. They're interested now. So we can't necessarily wait until the graduate level to tap into getting people excited about the weather enterprise, getting people excited about the UFS, okay? And expanding opportunities to court non-atmospheric science majors, which is what I mentioned. So we've had a host of different interns in WPO in the Weather Program Office. And what's really been exciting about that, we've had Pathways interns, Canals and AAAS fellows, La Pinta interns. What's been really interesting, though, is that not all of them have been atmospheric science majors. We've had majors in geography, in communications, in disaster sciences, advertising, transportation sciences, and all of them had unique perspectives to add to their intern experiences or their fellowship opportunities. So just staying within the lines, we got to start coloring outside the lines. Just looking at atmospheric and oceanic sciences majors is not going to cut it. And so here's just a kind of a map of the student and rotation opportunities. Yes, John, I stole this from your presentation. Thank you for that. And here's our current interns. So 3 of them I said are in our audience today, Alikia, Laura, and Emily. Please take an opportunity to meet them because the reason why they're here is not only as summer interns, but because they're interested now. And we don't look at them as summer interns, we look at them as investments in the future. So if you have an opportunity, please reach out to them. We're also hearing a presentation later this afternoon from our inaugural Wings Fellows. If there are any other students that are here, please reach out to them because they are thirsty to be part of the challenges and solving the problems now. And so I'm going to conclude with discussing expanding the web. And I'd like to touch on inquiry, insight, inclusion, information, and innovation. When I think about that, when I say inquiry, we need to be curious, not judgmental. For any of you that are Ted Lasso fans, you probably caught that. But we got to start asking some of the tough and sometimes uncomfortable questions of how we welcome more people into our community, how we make these connections, how we provide resources. Insight, be mindful that the playing field needs leveling, and consider seeing gaps, barriers, and obstacles from multiple vantage points. Sometimes we don't see them from our own vantage point, but if we expand that vision and have more insight, again, and empathy, we can start solving some of these problems and being more inclusive and open. So inclusion, be welcoming to other perspectives, is going to take a village to solve many of these problems, and there's more than enough room at the table. Information, being willing to share resources, data, and information. The old ways of competing against one another need to be retired. We've got to do better in connecting with one another through that web. And innovation, be open to thinking more radically and outside the box, and embrace the multidisciplinary approaches to old problems. So by broadening the Earth system community modeling under UFS and EPIC, and I kind of look at EPIC in this Spider-Man theory as being the web that kind of connects it all together, and kind of the multiverse. Like, I don't know where it's going. I'm not sure sometimes, but I think if we stick with it, it's going to really get us to some really great results. Establishing new collaborations with non-traditional partners, reinforcing integration of social science into UFS applications, provide equitable resources and access for partners and new collaborators, leverage future opportunities while promoting innovative, high-risk, high-reward approaches, create, develop, and sustain mechanisms to develop the next generation workforce, and expanding our DEIJA efforts, not only for UFS, but as partners all across the weather enterprise. And with that, I want to thank you for listening, and I will take any questions.
Tamara, that was amazing. And for someone who modeling's not your jam, you really nailed Earth system modeling as Kingpin. So there was a lot of appreciative nods everywhere. I'm Gretchen Mullendorf from NCAR, and you know, when I'm working with our now generation, I'm seeing a lot of students that, yeah, they're like, I'm really into dynamics, I'm into doing a lot of math and computing, but I also would like part of my job description to be engaging with social media or engaging with traditional media, or I want to be going out into working in the community. Mm-hmm. And so I'm wondering if you've seen that at all, or if you could talk about, like, do we need to be looking at actually reinventing how we put together a job profile?
In my opinion, I would say absolutely. Social media is not going anywhere. It is the gift that keeps on giving, but sometimes it can also be a curse. We need to leverage it to our advantage. And there are many of us that are, I would say, a little bit more seasoned, that have locks of wisdom, that are not comfortable with being the front-facing or the forward. That's where this generation comes in. And they also have a way of connecting with their communities, whether it be through social media or other, because one of the things that we're really struggling with an issue right now that you all know is misinformation and miscommunication. But we've got to embrace how we communicate with the younger generation and then use them as ambassadors and messengers of our mission and our focus to now kind of disseminate that outward. So I would say yes, but I'm a little lower on the pay grade than Dr. Morgan, so that might be a better question for him. All right, I would say it's coffee time. Oh, Dorothy, how are you going to ask me a question?
Yeah, thank you, Tamara. This was a lot of fun. I wanted to tie your presentation back to Steve Smith's and the trying to get our forecasting to that last mile and moving from, what is it, equality to equity. Mm-hmm. I always get mixed up which is which. But basically, I mean, I think in order for the mission to succeed, we really need to diversify the workforce, and we need to get all parts of the weather enterprise involved. And I think also I've been worrying a lot about the climate situation, and it's a similar thing. People are not going to really start to take action and personal responsibility and personal engagement unless they're really part of finding the solution. So kind of bleeds, there's a bleeding between weather and climate, and both sides of that, continuum need to really, be involved and diversified. But thank you.
I agree. I agree. You have a question? Okay.
Hi, everybody. I'm Emily. I am one of the undergraduate LaPenta interns that Tamara introduced earlier, and I just wanted to comment on the topic of expanding the grid of what you're looking for when it comes to finding your new generation of the workforce, because I am a product of that. I am an undergraduate student, and I am not an atmospheric sciences major. I was an atmospheric sciences major, but the cloud physics and atmospheric chemistry in Calc 1, 2, and 3 were just too much. So my strengths lie in communication and policy and all of these things. And I've wanted to be working with NOAA since I was in the 10th grade. And, maybe 5 or 10 years ago, if I tried to come work at NOAA with my skills, I might not have gotten picked. But I got picked, and now I can use my skills to help improve NOAA and make a difference. So just keep that in mind, that there are people with skills outside of what you might expect, and they can also be incredibly helpful to your efforts. Thank you.
Thank you, Emily.
Thank you, Tamara, for an incredibly engaging presentation. That brings us to our break. So we'll have 30 minutes. Feel free to get up, stretch, chat with people, use the bathroom. We would like to start promptly at 4 p.m. So if you could aim to be back here at 3:55, 3:58, getting situated, that would be incredibly helpful to keeping everything on time. Thank you, and see you in half an hour.
it's not clear which order the slides are in.
What slides do you want in what order? Because now's the time for.
Yeah, I mean, they're in the order they're going to be in. So we'll just have to figure out how that's reflected in how we run it.
Okay.
So we're gonna, yeah, I will. So we're gonna call them up. Well, actually, they're gonna talk from there. So can we have them seat in order that they'll talk, maybe?
I do not know I don't know what Bill Parker looks like. I know Bill Parker.
Neil there, and I just told the lady that he needs to come in for better.
Okay.
I couldn't find Sam or Bill Parker.
This right here, I think slides too, if it's easier for you.
I don't know.
I'm gonna have to read off mine. So.
Name tag this morning though. But it could be seeing. Mike Farrer is supposedly the only one that's virtual. He's the only one that let us know who's virtual. So. I wish I knew who. I don't even know where he's from. He's from a different university.
2-minute warning.
We should ask for Bill Parker over the mic, because I don't know what he looks like.
Can we ask them to come?
Should someone named Bill Parker come to the front of the stage?
The name is
So I think that Shakira and Senna, the only ones that have slides.
Yeah, they are the only ones.
Okay. So then we can just do Danae and then Mike. Okay. Please, yeah. How's it going? Good.
Press them on, and then as soon as you're done talking.
I think we have a remote. Okay.
It's about 4 p.m. now, so if everyone could start heading back into the conference center so that we could get started, that would be great. Thank you.
Oh, it's where'd you put the? Oh, she has to click her. That's why it's.
That and then you can speak.
All right.
Yeah.
Shakira.
Yes, I like that.
Shaquila, you're third. Sorry, I say it wrong. Shaquila. Okay. I'm not looking at my
Shakira.
notes. So sorry.
Like a music started.
All right. Our panelists are getting settled in. So if everyone else can also come on in and get settled, that would be great. ready to start? All right. I think we're about ready to get started now. I hope everyone had a much needed break. Next, we welcome Mr. Kevin Garrett and Dr. Mao-Yi Huang, who will moderate the panel on the importance and need for diversity and inclusion in community modeling. A quick note before we get to that, I did mention that the slides for all these sessions would be posted, and they will be, but they are not yet posted. After the conference, there will be finalized slides posted on the workshop website. So you will have access to them. Now, to introduce our moderators, or co-chairs for the panel discussion, we have Mr. Kevin Garrett, who is the Modeling Program Director at the National Weather Service, Office of Science and Technology Integration. He oversees management of several NWS modeling programs and is particularly focused on transitioning the NCEP production suite to the Unified Forecast System. We have Dr. Mao-Yi Huang, who is the program manager on the federal side for the EPIC program. She is, sorry, I have to read the little print here. So prior to joining WPO, she was the Coastal Act program manager and the lead of land, water, coastal, and cross-cutting infrastructure program areas with the National Weather Service, Office of Science and Technology Integration. Her scientific expertise lies in understanding the complex multi-scale interactions of hydrologic, ecological, and atmospheric processes using an Earth system modeling approach through model development, applications analysis, and model data integration. As heads of two of NOAA's offices, they care a great deal about inclusion and how we can make NOAA, EPIC, and the UFS a more diverse and welcoming place so that we can, in fact, improve innovations into operations. Thank you.
Thank you very much, Jan, for that great introduction. I want to also thank my colleague, Tamara, who actually just gave a very good introduction on why we're having this panel discussion. So after that earlier presentation, you might all see that why we want to make UFS more inclusive and also make sure it is accessible to all. And I really appreciate that Kevin and I work together to put together this diversified panel and with very diversified background to tell you their experience about building a diversified and inclusive workforce. Without further ado, I want to introduce our Neil Jacobs as the UFS Senior Chief Advisor. To give us opening remarks. And then afterwards, we're going to introduce the panelists, and then we can start the panel discussion. So a lot of you actually know Neil, and he is currently the UFS Senior Science Advisor within UCAR. And Neil was the previous Assistant Secretary of Commerce for Environmental Observation and Prediction, and the Undersecretary of Commerce for Oceans and Atmosphere from 2018 to early 2021. Prior to joining NOAA, Neil was the chief scientist at Panasonic Avionics Corporation, where he actually directed the research and development of both the aviation weather observation platform and weather forecast model programs. So he has a lot of experience in both the government and the private sectors to advance modeling systems for forecast purposes. And so he will tell us why he chose to be the UFS Senior Advisor. And then we're gonna get Kevin to introduce the panelists.
Good afternoon, everybody. I thought about truncating these biographies, but we have such an esteemed and awesome group of panelists up here. I wanted to really give the details of what they provided and their experiences. And then I'll just ask, this is a panel, so we want everybody to really be engaged and get ready to ask questions at the end and really maybe draw from experiences you had and get some insight from the panel on how we can overcome a lot of the challenges we have in this area for UFS. So first, Dr. Sun Chao is the director of the NOAA Cooperative Science Center in Atmospheric Sciences and Meteorology, NCAS-M, and a professor of interdisciplinary studies at Howard University. NCAS-M is a research through education enterprise led by Howard University and includes 8 other institutions. As the center director, Dr. Chao provides the executive leadership for NCAS-M through strategic communications, design of the overall scientific focus and plans, and provides oversight, management, and planning for the implementation of all aspects of the NCAS-M programmatic activities. Next up, we have Dr. Shaquila Merchant. She is the director of CUNY High-Res. I'm not gonna sound out that acronym. Maybe Shaquila wants to. She's also the deputy director of CUNY Crest and deputy director of NOAA Assessors. Before she moved to the United States, Dr. Merchant worked as an environmental scientist with the Ministry of Science and Technology in the government for India for more than 10 years. And after moving to the United States, Dr. Merchant joined NOAA, the NOAA Cooperative Science Center of the City College of New York in 2002. In partnership with the NOAA JPSS program, she developed the NOAA JPSS Students Professional and Academic Readiness with Knowledge in Satellites, also known as SPARKS, program to provide pre-workforce experiential and professional training to students, particularly from underrepresented minority community and women of color in NOAA. She's been a key member of designing the Individualized Students Development Plan and Professional Advancement and Career Engagement, otherwise known as PACE, Best Practices. She served on the AMS Education Symposium Committee from 2020 to 2023, and is currently serving as the co-chair of the AMS Education Conference Committee and leads the K through 12 informal learning initiatives at CCNY, and has done that since 2010. Next up is Dr. Danae Carlis. Danae is an award-winning meteorologist and serves as the director of NOAA's National Severe Storms Laboratory. Prior to NSSL, Danae served as the deputy director of NOAA's GSL, or Global Systems Laboratory, here in Boulder. And prior to GSL at the Weather Program Office in Washington, D.C., where he was the founding program manager for EPIC and the Next Generation Global Prediction System and GGPS programs. Danae was the second African-American male to receive his PhD in atmospheric sciences from Howard University. Next, joining us online is Dr. Mike Farah, who is the director of the National Centers for Environmental Prediction, where he oversees 9 National Weather Service national centers. Mike was the 2021 president of the AMS and currently serves on the AMS Council and Executive Committee. Mike's prior positions include chief scientist for the United States Air Force, senior VP and chief operating officer of UCAR, director of NWS's EMC as well as MDL, and VP of Strategic Development of Science and Technology Corporation, or STC. And finally, Mr. Bill Parker, who currently serves as the meteorologist in charge, or MIC, of the National Weather Service, WFO, in Jackson, Mississippi, and is the chairman of the National Weather Service Southern Region BIDE Council. He strongly believes in serving his community and is a true and passionate diversity champion. Over his 28 years of service within the National Weather Service, he has successfully recruited more than 100 students to work in NOAA facilities through volunteer and internship opportunities. As a result, Bill has received 14 awards directly related to being a diversity champion and promoting STEM education and outreach within NOAA. And with that, we'll welcome Dr. Neil Jacobs up here. Thanks.
Thanks, Mary. Thanks, Kevin. I quickly just wanted to thank everyone for coming out for this. I heard that we are way over capacity in the room, although maybe I shouldn't say that. And there's at one point over 700 people joining in online, which is amazing that we've gotten this far in just 2 years. I also wanted to give a quick shout out to Jen Butt, Jessica Wheeler, Aaron Jones, Carrie Dawn Solar, Kelvin Tavares, and Jesse Webb for all the work that they've done in putting this together. Yeah. This was not easy, I can tell you, because I lurked on some of those calls and yeah, tons of work. And also, Big shout out and congratulations to the LaPenta interns and the Wing Scholars. I know he had to leave, but I did want to thank Dr. Mike Morgan for coming out here. I can tell you from firsthand experience that his schedule is relentless, and this shows what a priority this is for NOAA, and I think it's a really big deal. It's really important. So thank you, Dr. Morgan, for coming out and spending the time with us. I was thinking about what I wanted to say on this issue because I'm probably the least qualified to speak on it, but it's really, really important. And I went back to a policy statement that I wrote when I was at NOAA, and this quote has been used more times than I expected it to be, but it says, "Without diversity, we limit our ability to innovate, and without inclusion, diversity becomes meaningless. And any benefits associated with diversity will not be realized. The two concepts are inseparable, and they begin with an inclusive environment." And this sort of hit home for me last year. I don't know if you remember if you were at this conference last year when Jamise Sims was talking, but she said something, and I can't get the words out of my head. She said, "I was in a lot of meetings, and I would look around, and nobody else there looked like me." And I can tell you that I was in those same meetings, and she's right. And I started thinking about that over the last couple of days and realized that as individuals from underrepresented groups advance through their career, they quickly run out of role models that they can identify with. And the further they get in the career, the harder and harder that is to find. And I can't stand up here and tell you that I have any idea what that's like, because I don't. It might surprise you to learn that I have family members that come from underrepresented community, but the reality is I'm your average white guy, and I can't in any way relate to Jamise's experience. But it doesn't mean I shouldn't try, at least to empathize or try to do something about it. And so when we were putting together the Community Modeling Board Charter, you'll see language in there that focuses on this. And there's a million different reasons why it should be in there. And I just wanted to pick one to talk about today. And a lot of times you see these charters and policies and people feel like they have to write all this stuff in there, but they really don't stand back and think, why am I writing this? Why is this important? When I started with the UFS and the community modeling, I had a singular focus, and that focus was, I want to crowdsource model development to have the most skillful model in the world. And the longer I've been involved, the more the focus has shifted from having the most skillful modeling system in the world to having the most used and embraced educational tool for environmental sciences out there. And I really feel that that's the true value of this community modeling system, is really as an educational tool, because it occupies the nexus between a really powerful mathematical capability and understanding the planet that we live on. But who's the community? Well, I originally thought it was software engineers and scientists, and then I started thinking, well, maybe it's graduate students or undergrads, and now I'm thinking it's K through 12. This is where I think that we can actually have the largest impact. And I'll explain why this is important in a second, but part of the goal of this community modeling system, particularly as an educational tool, and particularly in the K through 12, is really looking at, do they have access to these tools? What do they need? I know they don't have access to these tools. They definitely don't have equal access to these tools. Most of them don't even have equal access to a proper education at all. And do they have role models? That's where I think that the language in a lot of the policy statements that you see in the Community Modeling Board draft and the UFS, it's really about role models. The focus, And like I said, I could list a million reasons why this is important, but one of the most important things, I think, is that underrepresented groups in K through 12 and even undergrads see people that they can identify with as role models. So I firmly believe that kids in STEM, they need role models that they can identify with. This is incredibly important. And it's up to us to make sure that that's a priority, that we have representation across the community modeling groups, all these everywhere, whether it's the governance, the leaderships, the application teams, whatever, particularly with the outreach and all that stuff. When we're going out there, you know, I used to say I'd go on these road shows to universities, but now maybe I'm thinking like middle schools, high schools, elementary schools. I mean, they're writing code in 4th grade now. That they see people that they look up to as that's someone that I can identify with, and I want to grow up to work in environmental sciences and do Earth system modeling. To me, that would be a successful win for the UFS. So I'm excited to hear what the panel has to say. I think that this is an incredibly important discussion and something that we need to have as we start to build out a lot of these groups and these teams and the governance. And just something that we should just keep in the front of our mind and the entire time we're going through this process. So thank you again for coming. And for those of you online, thanks for listening in. Really excited about all the progress we've made. I know it's easy to sort of get bogged down in the minutia of code release and you know, fighting over workflows and infrastructure, but we've made a tremendous amount of progress in the last couple of years. It's pretty amazing to see what's going on. So anyway, thank you.
Thank you. My name is Sin Chao. It's good to be here. Good to see you all. I know, I think one way or the other we saw each other, but I'm very bad with names. Sorry about that. But again, it's good to be here. I think from noon to now, we talk about the opportunities, challenges, the excitement, progress. And Tamara basically touched on the DEI, which gave a very good summary about that. And I want to give a quick version of what is the CSC, the Cooperative Science Center, which we have 4 of that actually under NOAA funding. So NKSM, which is here, basically, I have to confess, I kind of put the slides like last Wednesday night, the deadline. So, but bear with me. Too many words here, but I'm not going to read it. But each CSC has a different mission. So NKSM, which is, we are focused on National Weather Service. So on the left, you can see that from the observation to the modeling to the societal impacts, integration on that. And the most importantly, again, what we are trying to do is, this is actually this is pretty much the bottom and bread. I want to say that for the, I want to say future workforce, for the workforce now or in the future. Through the training, through the education, we are targeting an underrepresented group, as well as we are on the mission that along the line with NOAA tasks. So this is actually a very important part of that. That's actually how we align ourselves in terms of the training our students. We basically handpick, not like handpick, but we basically choose our students and train our students pretty much from the beginning until they graduate. Even after that, they help them find a job at NOAA. So this is actually how we do. Just want to highlight the bottom part of that is the training and the developing workforce, providing opportunity for them. So, but along the line, actually, I want to mention that in terms of the challenges that we are dealing with If I can move on to the next slides. The challenges, again, too many words, you don't need to read, but I want to just highlight that the challenges, again, which easily talk about the DEI, but how to implement, how to make it work. Diversity, equity, inclusion. How to do it. Most of us actually can say that easily. However, when you to the level implementation, that's really challenging part. But again, that's what we do. But by the way, I'm not a fan of Spider-Man, but I'm the fan of Mission Impossible. So the new one is actually pretty good. So again, we basically, see the future, see the needs, just like Neil just mentioned that. The role model from the K to 12, we actually see it. And we are actually, at the end, near the bottom, trying to make it work. A lot of challenges, a lot of good news, a lot of things we celebrate. And that's actually an ongoing process. So again, we engage a lot of things with our colleagues at NOAA. Again, as you can imagine, that from all kinds of things, from the weather to the climate to air quality, pretty much every single thing that we want to engage, we want to provide students, we want to engage colleagues from NOAA and then pair with our students. So that's actually what we do. And this slides basically summarize the past 5-6 years that we did through NOAA EPP support, that we were able to, again, generate different research results, train the students, and how the mission that we engaged. That just want to echo what Tamara was saying, that we did a lot of things. We are here. We are ready to engage on tasks. The picture here that's showing some highlights that we had. Now, I want to end with these slides, actually, for my part. So after, again, back to Tamara saying, CSC, after 20 years plus effort, we finally established a new department, which is the E3, the Earth, Environment, and Equity, the E3 department at HBCU, at Howard University. This is actually one of a tremendous step that we, through the support from NOAA, we were able to move into that direction to really train our students, to recruit our students, to retain, to generate the future workforce. I want to take this opportunity to let you know I'm here, I'm at Howard, I welcome you to visit or contribute or any suggestion or comments that we can help our underrepresented community, help the university, help this new department. I'm welcome your suggestions. Thank you.
Okay, great. Thank you so much, Sen and Neil, and thank you for the opportunity to be on this panel, Kevin and Maui. And I must also echo that Tamara has laid a foundation for us, so it is much easier for us to talk about who we are. Thank you so much, Tamara. And one more fact, Tamara was one of the graduates from my center, so yes to that as well. And of course, Christopher Spells is also from the center that I will be talking about. So again, thank you for the opportunity. And I am with the NOAA Center for Earth System Sciences and Remote Sensing Technology. Just to give we did see how we are CSCs versus CIs. There are only 4 CSCs across the nation, and probably there are 20 CIs within NOAA. So within the 4 centers, NCAS-M that you just heard is one of them, and the 3 other centers are created a consortium of 24 university systems within the nation. And more than 80% of these institutions are HSIs, MSIs, or HBCUs. So we are really impacting on a large population within this network. And we have been in existence since 2001. And each center has been provided a portfolio so that we are not doing the same science or training the students in the same NOAA mission across these centers. So each one of us have a research portfolio, but also assigned to a line office. For example, we are assigned to Nestus because we're a remote sensing technology center, and CASM is assigned to weather services, and Florida A&M, the coastal and ecosystem center, is assigned to ocean services, and marine fisheries science center in Eastern Shore, Maryland, is assigned to fisheries. So as you can see, we are also have a bigger footprint within the NOAA agency as well. So the metrics or the goal of EPP-MSI, which is Educational Partnership Program within Minorities Serving Institutions, which is through the Office of Education, is same for all the 4 centers. So the training that we give to our centers is equitable. Of course, we have different best practices or initiatives that we would be bringing to our centers because our science is different that we are training our students. Each one of us have different research areas that we are assigning or thematic-wise distributing the training of the students, so we are more holistic, but also we are aligned to the NOAA mission as well. So we are a unique model. And I can say this as one of the foundational member of this program since the inception in 2001. It's holistic because we are preparing the students not only to become good researchers, but also to become better professionals and prepare them for future NOAA workforce. And there are many of these CSC products here in this room, Tamara, Chris, and of course, Danae here besides me. So we are really a very holistic model, and I think it has been also mentioned in the COSTEM report during President Obama's administration as well. Just the numbers here, again, one thing to be highlighted is our program really focuses on engineering graduates. So more than 60% of our students are graduated in engineering degrees, but the point here is that more than 75% of the students are traditionally underrepresented communities that go through our programs. And then, of course, we graduate equal amount of students. Maybe there's attrition of maybe 10 to 20% of the students, but most of them do graduate. And as you can see that, again, the graduation of the minority students is pretty high through this program. This slide is something that I wanted to share is, as you can see, the majority of the students who graduate do end up in the private sector. I mean, of course, engineering degree, 6-figure salaries, it really is very enticing to students to go into industry. Very few students have ended up in NOAA workforce as federal employee, and I think there is a gap, and we have still much more to do in terms of how we can really understand the challenges that we have in recruiting and training the students and graduating them, but how do we really bring them into the NOAA workforce? Some of the capacity that we have been able to build, because in order to do the education and training, we can't just do it alone. We need to have some capacity where the students can really get the hands-on and minds-on training. This is a slide that I'm trying to show only from the weather perspective or climate perspective that really may be aligning with the audience in this workshop, how we have built the LiDAR network on the East Coast across New York, Maryland, and Hampton University. But again, it's a partnership between several agencies, 2 cooperative science centers, and also Cooperative Institute and many MSIs. Again, Long Island Sound services that we have, observatory for coastal water observations on the Long Island Sound. And also we have, our students have been engaged in field campaigns, and one of them is actually going on, the Aroma in New York City. But the idea is to really engage students in not just classroom training, but also be prepared in doing the application-based research and training. I also wanted to share some of these slides because K-12 has been discussed so much, and we have all probably in this room acknowledged the fact that we have to start this training early on. You can be grass tops if you're not grassroots, right? So we really run this program for K-12, and I have been running this for last 15 years, so no summer vacations for me, because this is the time, this is the time when the students are really out of school, and they're really understanding atmospheric physics and chemistry and meteorology, and they also go to the National Weather Service office in Uptown Long Island to really see NOAA in action, and which is very important for them to understand that this is the career that I want to be in when I go to college. And then when they're in the college, when I want to be in the workforce. So this pipeline really begins early on. So what it means for them to be weather ready or climate ready and water ready. So we really have the students immersed into research programs and projects alongside of faculty advisors and graduate students to really work on understanding what it means to be science service and stewards of in terms of NOAA mission agency. So students learn about that directly by the NOAA mentors, but also academia as well. Again, some pictures of how students are networking with the forecasters and understanding how the weather data is coming through these balloon launched in the radiosonde and trying to download the data and analyze that as well. And they also get training in remote sensing, GIS, and Python, which is where the future workforce needs are. Another aspect of where we engage the K-12 is sensing one borough at a time. We have 20 weather stations that have been instruments being installed by our students, and most of these instruments are within the school system, which are part of our network. So these students and the teachers serve as ambassadors to the weather products coming out of these weather stations and connect that to the weather within their community. And it is very important for them to learn about this, and then they are pipeline into our high school program and onward to becoming a NOAA CSC fellow. So again, these are some of the sites where we have our weather stations, and students are actually collecting data. But of course, a lot has been happening due to COVID, and most of these stations are not working, or there were challenges. But we are really trying to rebuild and connect that boroughs together. So again, it is all about creating those partnerships. Creating this community dialogues. It's just not, it takes a village to really create that kind of community of practice. And I always say community of practice. So really training and educating students is just a whole system that has to be engaged. So my last few slides, just one more, I guess, is a take home as how do we build on these existing models that we have been able to develop for the last 2 decades. So it has been tested that we have best practices in recruitment outreach. Tamara did mention about why do we only go to AMS and AGO? Sure, we have to go to diverse society and conferences like SACNAS and leadership, and I have firsthand experience of recruiting students from these minority-driven conferences. I have also developed the JPSS Sparks program that is a perfect synergy of private sector, academia, and federal partners working together, where private sectors can then take those interns as a future employees and bridge that pathway. And again, of course, summer programs that we run, and then the NOAA internships that we know about. These are best practices, and how do we go forward from here? So how do we build the capacity within the MSIs? And Tamara again had mentioned this, that there are challenges. Most of the MSIs, HSBCU are not even R1 institutions, so we don't have some of those capacity building. We don't have cloud computing facilities for that matter, with the same resources that we are all trying to compete for when we are doing the summer program. So what is that holistic and inclusive environment that we can bring so we can really hone that capacity building for the institution? So my last slide is a model of how we can create these academic programs. In 2006, we invested in creating an undergraduate degree. It's a dual degree in science or engineering. Based on where the students' interest and credentials are, they can get a degree in Bachelor of Science or in engineering. It was ABET accredited, and then we were highly encouraged to create a master's degree, which happened in 2012. And then in 2019, we created a data science and engineering degree. So a lot of AI, ML is now coming into play. And in 2023, we are hoping to have a PhD program. So this is the timeline of our ESE program, but because I'm a K-12 advocate, I'm also trying to get an ESE program at K-12 level. And really have some teacher ambassadors to really bring this. What does it mean to be modeler? Why can't we start, again, the K-12 curriculum is still 50 years old and the problems are 21st century. So how do we bridge that gap? So we're hoping to really connect these two dots, K-12 and PhD, and how we can bring the modeling community or modeling knowledge at the classroom level. So I think that is all I have. Thank you so much for your time.
All right. So Danae Carlos, I'm at the National Severe Storms Laboratory, new director there. Just got there in January. And I was actually going to take my presentation a little bit differently and give you all of these smart things to implement. But instead of that, I'm just going to tell you some stories. So, when you look at what Neil and what Mike are going to be talking about here, I think it's really important that people that aren't from minoritized communities show up in conversations like this. I think it's important that folks that aren't from minoritized communities show up in universities that don't look like their university that they attended. And I think when you look at some of the conversations that Sin and what Shaquila just mentioned, you look at the amount of structure that you have to have in order to get students from underrepresented groups into these spaces. That's an incredible amount of time, commitment, and just overall infrastructure that is required in some sense to get a student from the north side of Tulsa, Oklahoma, to be a scientist within the agency that is NOAA. And so when you think about that, I think representation, it really does matter. And I am very much so, I look back on my childhood, the first time I met a scientist was one of my friend's fathers. He happened to be one of the few black medical doctors in Tulsa, Oklahoma, where I grew up. He was the one that inspired me to be a scientist. And it's because he was able to relate to me. I was able to have conversations with him, and he would sit me and my friends down on a Friday night before we went out to go do something stupid. And he would talk to us about science. He would tell us stories about science, what it meant to be a scientist. He talked about him blowing up a laboratory when he was in the 10th grade during a chemistry experiment. And it was those types of things that really caught my eye and made me want to be him, right? But once I took biology, I knew I didn't want to be him anymore. And so I went into chemistry. And I went into chemistry because of Dr. Vernon Morris. And Dr. Morris was one of those people, one of those types of people. He was similar to Shaquila. He's like a father figure. Shaquila's like a mother figure to a lot of those young people that came through Cessert and Crest. And you have to be committed to them. You have to be really invested in their future. Like for me, my dreams was to be the next Michael Jordan, as you can see with my bald head. It wasn't to be the next great scientist, and it really was the people that were doing the work that were part of the field. You know, you guys are part of the field. You guys are the ones that can provide that glimpse into the future that can make a young person actually believe that they can achieve. And I think that's the thing that if we continue down this particular path, that we have to continue to do. Help young people see their dreams and fulfill their dreams, because a lot of them, they don't necessarily have any, especially as it pertains to science and engineering. And so we have to be that representation for them in order for them to see themselves in this particular field. And so the other thing that I'll mention is, you know, with regards to, you know, the Vernon Morrises of the world and Shaquilas of the world and Sins, like you can't let these kids go. Like, you have to help them along the way. I was very much a knucklehead, to be honest. And I probably could have used some of that professional development that you guys now have, because I definitely wasn't doing what I was supposed to be doing all the time. But at the same time, you know, I always felt like the people that were part of the program, they cared about me. They knew what my potential was, even when I didn't necessarily know it myself, right? And then it was people from NOAA coming to Howard University. Steve Lord came to Howard University on multiple times, and I asked Steve Lord used to be Brian. So he was the EMC director at that particular time. And I asked Steve, I said, what do I need to do in order to get a job at EMC? And the first thing he said was, you got to learn how to program in Fortran. And that was, and he gave me like 5 things. And I was basically a new PhD student. And I didn't know anything about numerical weather prediction, but I saw some Viz 5D graphic of clouds, and I was like, I want to do that. That's why I got into numerical weather prediction, is because it was NOAA people coming to my university and showing me what it is that they do. And that part of it just blew me away. And I said, I want to be the next Steve Lord. I want to be the next, I think Jordan Alpert came at some point. And so that's really how I got into this particular field. And, you know, I spent the next 5 years basically doing everything that Steve told me to do. And when I was done at that 5-year mark, I knocked on Steve's door, and I said, Steve, I want to come work for EMC. I did all of the 5 things that you told me. And 2 months later, I had a job at EMC. That's how I got to EMC. And then how I got to GSL as the deputy director is getting an opportunity to work with Jennifer Mahoney. And I told my wife, when the GSL deputy director position opened, I told her, hey, I'm thinking about going and applying for this job at GSL. And she said, well, tell me a little bit more about it. And she said, I told her that I would be working for a woman. And she said, oh, you got it. You can go apply for the job. She said, you need to go work for a woman. That was the first time that a female was actually my supervisor, was Jennifer Mahoney. And Jennifer was the reason why I actually came to GSL. So I'd say all that to say, I think all of these things are really important. Representation is important. I think the K through 12 aspect of what we do is going to continue to be more and more important. I see it, you know, the UFS really as a citizen science opportunity for us. And I think in terms of just our ability to create opportunities for young people, I think that was really part of the conversation when we talked about EPIC back in March of 2019, is that in order for EPIC to be successful and the order for the UFS to be successful, we really had to reach down into, you know, the grad students and the undergrad students as, just key pillars of the future of our organization. And so UFS in general has adopted that and has been really trying to push and move that aspect of creating opportunity and creating new scientists and engineers that are using NOAA modeling systems, creating those opportunities to see those young people advance their careers. And so happy to have all of the LaPenta interns here and the Wings Fellows. We've been planning for this for a while, so glad to have you guys here. So I'll stop there.
Dr. Farah, are you still online? All right. I'm going to go back to the general slide display here. I don't think you have slides. Go ahead, Mike.
My turn? All right. Can you all hear me okay?
Yes.
Okay. Well, thanks. My apologies for not being there in person. I really would have enjoyed coming out and spending time with a lot of my friends and colleagues. A lot's already been said. I feel like, I don't know if I was batting cleanup. I think you let me, I like the pitcher that gets to bat at the end. So there's a lot of good stuff that's already been hit. But I do want to focus on a few things. Maybe looking from my perspective, that's perhaps a little longer in the years than some of the other folks. And we've seen a lot of change over the last 20 or 30 years, but more than one speaker or panelist talked about inspiration. I mean, I come from a generation, I was born in the 1960s, and there's a lot going on that wasn't great, but the one big thing for science and technology that was happening, of course, was the moon race during the 60s. And a whole generation of scientists and engineers were inspired by that, and I was one of them. That's why I was interested from a very young age. I think we got an equal opportunity now with climate change and what's happening today. It's just a big deal. Everyone's talking about it. I think we have a golden opportunity to inspire a whole other generation of folks, and both Shaquilla and others talked about, we can't just start at the graduate level. We have to go down to K through 12 because, frankly, I don't think our success is going to be measured. And even I'm a NOAA senior leader, I really don't think our success is going to be measured in how many people we can get out of school in underrepresented groups and as NOAA employees. I think our success is going to be measured much broader than that. Just having a basic science literacy that cares about this discipline, that understands the basics, I think is really what we should be shooting for. We need to grow there's a slice of pie for a lot of us, so we need to grow the pie dramatically. So that's a big part of it. But we're just the opposite in some areas. I mean, if you look at data assimilation, for example, and one of the hubs in the United States for data assimilation is where I work in College Park, and one of our centers, of course, EMC, where I was a former director. And out there in Boulder was one of our NOAA laboratories and the Joint Center for Satellite Data Assimilation, where our core staff sits there. They didn't just go out, put out an advertisement, and sift through hundreds of qualified volunteers and applicants and pick the top 10. This is a global shortage of science and technology expertise, particularly in specialty areas that we need. The only reason we've gone so far with our Joint Center Project JEDI is that we've poached a lot of the good people from Europe. And of course, they're going to do the same to us at some point. There's not enough to go around. So I look at this, one thing, I'm a NOAA employee now, but my biggest part of my background is with the Department of Defense, particularly with the U.S. Air Force. And so I think of things, not just in science, but also from national security lens. I think the lack of science and technology expertise is a national security risk. It is something that impacts us at many levels, and we really need to grow this pool for our own security, for our country, for the future. And how foolish will we be when we're already short of any qualified folks that we wouldn't go after everyone? We wouldn't go after the widest diversity of people we could from a pure numbers game alone, not even getting into the obvious moral and ethical reasons for wanting to have equitable representation. Just from a pure security standpoint alone, this ought to motivate us. Because basically the future of the human race is going to change. We're already seeing change in our climate. We're already seeing this is not something that's going to happen in the future. It's already happening. And there's going to be a lot of things that are going to be required to deal with that. And almost all of them are going to have some kind of science or technology need to it. So look at it from my perspective, we got to go all the way down to the lowest levels of education, down to undergraduate, to K through 12, get kids interested in science and technology again, the same way that happened when they looked at the space program in the 60s. They need to see opportunities and making a difference. There's so many more socially conscious people at this young age. It's not what are the movie in the 90s, the Wall Street or Greed is Good. Kids aren't like that anymore. I mean, they're socially conscious. They want to make a difference for the greater good. They have to be able to see science, particularly our science, as an outlet for that desire. So it's not about just like the old days. You're talking about meteorology. We need more people from the bigger schools. So, I mean, I went to Penn State for a year. It's a great school. And they play a role. We need to grow the number of schools. We need to grow the number of programs. We need to reach into smaller programs and help them grow. These are not just, the schools we've all heard of, in the big schools, maybe you see up at some of the presentation, we need to get down to smaller schools, community colleges, and certainly the MSIs, the HBCUs need to grow. Can you imagine, Danae, where we'd be right now in terms of PhDs with Black Americans, one for Howard? That's just one school. We can't have that. We have to grow that beyond Howard, although Howard is a national treasure. It's just, to me, it's almost it's a national embarrassment that we don't have more and many more schools. And thank God for that Howard's there. Where will we be now? We need to grow all of these things. And then it's not just about creating people that are able to come in and get a job. We need to retain them too. And so this is a DEI panel. We need to make an environment where people not just want to come and get hired, where they want to stay. A place to thrive, a place where they feel at home. And that's not just it's not just the ethnic or racial background, it's special needs folks. We need to make them more easily accessible. Brilliant people that we don't necessarily see. We need to get them into the workforce. And then frankly, one part of diversity that's obvious from science is disciplinary diversity. We need to, we're already moving beyond just meteorologists into other parts of the Earth system. We're going to have huge opportunities with data science and machine learning and artificial intelligence, but we need to find ways to track those people and get them interested. And it's not just about being our employees. We need to find other people in other departments and other disciplines and other organizations interested in the problems that we care about and bring them in. So I'm really passionate about this. Like I said, I want to wrap it up with something I started earlier. I really think that the lack of a diverse and deep pool of scientists and engineers is a risk to our national security. And not just because it's the right thing to do, because our future depends on it. And I think I love to hear what the panel has to say as we go and do a Q&A later. Thanks a lot, Kevin.
Thank you, Mike. And last we have Dr. Bill Parker.
Good evening, everybody. Bill Parker. I'm not a doctor. I'm like Tamara. I'm the only one up here that don't have a DR behind my name or in front of my name. And really, I don't even know how I got here. But I'm thankful to be here. I'm thankful to see what you guys are planning in the future as it relates to modeling. And as I talk, I hope I can speak some of the language. I hope I can just share a few things. I'm like Danae, I didn't bring any slides. But operational meteorologists, you know, depend heavily on numerical weather models. We depend heavily on those models. And if you don't hear anything else that I say, I want you to hear this, that modeling saves lives. And it saves lives for everyone. But when you really look at the severe weather impacts, when you really look at the people who are dying from these extreme weather events, it's minority and underserved communities. When you look at folks who can't rebuild their homes, folks who don't have the insurance, folks who don't qualify for FEMA, it's minority and underserved communities. And so as I've sat here today and listened and have been totally amazed with some of the things that we're going to see in the future and as it relates to operations, I want you to understand how very important what you do is to the mission of the National Weather Service. It's very, very important. And I'm thankful that Tamara brought out a point that students want to be a part of that mission and not so much focused on the money. When I look at the current models that we receive in the National Weather Service offices, and what we are doing to warn the citizens that we serve. I serve Mississippi, and when you look at the CDC Social Vulnerability Index, I mean, we cover it all. I mean, I don't know if there's a county that's not in dark blue. Most of the whole state's in dark blue. And so we need to let people who we serve know much earlier than a tornado warning. We just went through the Rolling Fork tornado. It was modeling that helped us start talking about that event 5 days in advance. If we were just talking about that one day and the day of the event, we would have lost a whole lot more people because people in those communities need more time. You heard Steve say that earlier. It doesn't just start with the short term. It starts in the mid-term and the long term for preparing people for these type of extreme events. We need modeling with more detail. I was excited to see Jim talk about 3D modeling. We need 3D modeling. I would challenge you, we need some 4D modeling so that we can communicate these events to our decision makers where that they can really understand the impacts that are going to impact their communities. If we're going to operate in this realm of IDSSS, we're going to have to be able to communicate at a much, much better level. We need models in the medium and long term to better predict the intensity and the magnitude of extreme weather events. And I say this because, as they've already talked about, when you look at who's being impacted, again, it's people who are in minority and underserved communities. I'm thinking of Rolling Fork. And one of the things that we do when we go out to schools at the National Weather Service offices, we talk about not just weather safety, but we talk about the impacts that models have and how we forecast and how we warn. And I brought Rolling Fork back up because we had a scheduled date to go to Rolling Fork and do a school talk, and a tornado hit that community 1 week before our scheduled school talk. We never had that school talk. And many of the students are not even coming back to Rolling Fork. 60% of that community were renters. Many of them don't qualify for help from the federal government as it relates to FEMA. And so, again, if you don't hear nothing else that I talk about, I want you to understand what you do saves lives, and it helps citizens to reduce their property loss if they can prepare in advance. I think of Hurricane Trina and my own family members. Many of my own family members, who I never thought would leave New Orleans, couldn't go back to New Orleans. They had to move to other places because they couldn't afford to go back to New Orleans. They didn't get the help that they needed beyond the event. If they had prepared for the event to save their property, many of them could have went back. The great thing is lives still were saved. Even though they couldn't go back, lives were saved. So these things need to be talked about as we look at the future of operational meteorologists. We're going to need tools to communicate better with decision makers. We're going to need that. As I look at the unified forecasting system that you guys have been talking about, what I think of is the consolidation that the National Weather Service kind of went through in the 1990s called MAR. And the Weather Service went through consolidating, went from 256 offices to 122 offices. You talked about modeling starts with observations. I know radars are a part of observations. We decreased the number of radars that we had. Our network surface observations also decreased. And so one of the questions that I was thinking about, and I want you guys to think about is, when I look back at the consolidation that the National Weather Service went through, was all of that consolidated effort a success? Or do we see some things looking back that we could have done better? And I'll just use an example of a surface network that I'm in charge of at my office, and most Weather Service officers are in charge of, and that's the Cooperative Observer Network. And it has a lot to do with modeling because, from my understanding, that a lot of our observations from our cooperative observers actually go into the models. And right when modeling was just getting started in the 1940s and 1950s, we had about 6,000 cooperative observers. As modeling really started taking off in the 50s, 60s, and 70s, that observer network went up to about 14,000 observers. Then we went into the modernization period, which is kind of like a unification. And in the 90s, it dropped off to about 12,000 observers, about 15%. Now, in 2023, we're around 8,000 observers around the country, roughly from the peak of 14 observers to about 8,000, which is about 43% from the max. And so my question, I don't know, my question is that amount of data loss critical to weather models? Are the historical data references from those lost sites, are they being maintained? And if they're not being maintained, could that help us really see better forecasts with the intensity and magnitudes of some of these extreme events? Could these lost data points have helped, again, with extreme weather predictions? And then I have three more questions as you guys move toward inclusion in a unified forecast system. And that is, will it be a diverse network? Y'all have heard that already. Will it be an inclusive approach? Heard that already. The third question is, will individuality be totally lost to achieve a unified model? That's a question I know a lot of young people want to know. Because as they become a part of what you're doing, they have passions, they have ideas that they're going to want to bring to the table. They're not going to just want to take on your passions and take on your ideas. And I close with this. As an operational meteorologist, I mean, I don't know anything about what it takes to put together a weather model. The consumer doesn't know what it takes to build a car. They just go and try to find a car that's good and that's reliable. Well, that's the way I look at weather models as an operational meteorologist. I'm looking for something good. I'm looking for something reliable. If you give me something good, if you give me something reliable, I can drive the communication that's needed to save lives from these intense, extreme weather events. That's it.
It's a coincidence that you were put last, but I think that really helped tie all the talks together. So thanks for that perspective. So now we're going to open up for Q&A. So if anybody has questions for the panel, please step forward to the microphones. There's one on each side of the room. Hendrik?
Hendrik Tolman, National Weather Service. Thank you all for your fantastic insights. I've always been a strong proponent of diversity needs, probably because I'm a civil engineer in a whole group of weather weenies. But the one thing I sort of kind of missed a little bit in the discussion is we need to attract the right people, we need to train the right people, but I was thinking about a discussion I had with Laura Forgione. She was the Deputy Director of the Weather Service, one of 3 in a row that we've had female. She was telling me on one of the first SES meetings I went to when we were talking about diversity, how difficult and how tiring it was for her to be, look around, there's nobody that looks like me, that she was the only female in the room and that therefore she had to be the token female on pretty much everything that needed to go on. And so I'm pretty sure that was one of the reasons why Laura left the Weather Service and started working for the census. So we see that in our numbers also, that we are hiring more diverse. We're not retaining more diverse. So any thoughts from the panel on, first of all, if you agree with me that retention is just as much a problem, and if you do, what can we do about that? Thank you.
So I agree with you. Retention is a problem. But I think one of the big pieces that keep coming up is inclusion. And as you bring people in from various backgrounds, from different cultures, different races, it's allowing them to be a part of what you do, but accepting who they are and allowing them to be who they are. I know a lot of students who come into Weather Service offices, and if they don't feel comfortable, if they don't feel like they fit in, and even from a knowledge base, you know, sometimes students are afraid to ask questions because they don't want to feel like they're dumb. They don't feel like they're stupid. You mean they didn't teach you that at Jackson State? That's where I went to school. Those type of environments where they can't come in and be who they are and express the knowledge that they have and feel comfortable, that's when they go to other places. And so retention is, you're right. It's one thing of bringing a diverse group of people into your environment, but there's another thing in keeping them there.
Yeah, and I think that's where the culture of an organization is extremely important, and I think that starts with leadership. You know, you gotta have amazing leaders at the top of your organization, and if they're not amazing leaders and they just want to do science, let them do science. Help that next person that really wants to work with people be the one to talk about and represent the organization in a management and leadership type of capacity. I think, you know, we absolutely have a retention problem when it comes to women, when it comes to Black and brown people as well. And to me, it's because we don't necessarily always see ourselves in the organization. And there's just so many opportunities out there. You know, we're competing for the best of the best. NOAA is, the private sector is, academia is, and we're all trying to diversify our workforces because we see the value in diversity. And there's a commitment at the leadership level. But if it's not the right culture, if I never get an opportunity to sit down with my leadership and have a conversation and talk about my experience as a African American male within the organization, then what am I doing here? Why do you have me here? I'm not here to be a token. I want to come in and make a difference. And I can easily go to some other organization because everybody's recruiting Black and brown people nowadays, and find my way, and women, and find my way into another organization fairly easily and make money too, probably. So I know we have multiple questions, so we probably should let more questions
Okay, no problem. Thank
So
you.
I'll allow somebody else to have a response if they have something quick.
Well, I just wanted to, sorry, I'm taking this. I'm not being able to resist not being a NOAA, because I'm not NOAA, I'm a NOAA friend and a NOAA agent, I would call myself. And as a historian, I've seen 5 administrators, and every administrator has a different way of engaging and the leadership. And speaking of leadership, I think leadership have the power to be that DEI lighthouse for the agency. And I think the sense of belonging is so critical that if you really go to some place and feel that, oh, I want to make a difference, and do not get that support system, do not get that kind of sense of belonging and inclusion, you really find a way out, and that's why retention is always a challenge. So I just wanted to add that.
All right, thanks. Just a time check. I think we have about 15 minutes. Okay, so we'll go to this side of the room.
Hi. First of all, thank you. This is amazing. I have a question that I didn't get an answer for in another format, so sorry to give you the challenge, but I thought you all were up for it. The NOAA Pride ERG had a really good discussion about evolving in your career, and one of the things that weighed really heavy on my heart from that was adaptability is kind of the main factor in success. And this is a loaded question for me. I'll admit I'm a trans man, and I don't think I've met someone else yet at NOAA that's trans. I just wanted to put that out there because I feel more comfortable in a diverse setting because I'm not alone in a very fundamental way. And I think that lots of marginalized communities feel that way, and inclusion affects everybody. But I think we all know that a lot of the people at the top look the same. And even if you can't see diversity, visible or invisible diversity both have a role, I think, in how an organization plays, is what I'm trying to say. So my question is, for the people from marginalized communities, all of us, how do you balance adapting to the present culture to advance in your career, to contribute to retaining your sense of self that makes you who you are in the first place?
Don't all start at once. All right. No, I mean, I think that's a fantastic question. And, you know, I kind of look back over my career and I think one of the reasons why I stayed at NOAA is because of the mission and the people. There were people that didn't look like me that took a keen interest, and one of them was Bill LaPenta. Took a keen interest in seeing me flourish in this organization. And I think if you don't have mentors and sponsors that you can just have a conversation with, like if you're having a tough day, like who's that person that you go talk to about that? You know, it could be a peer, it could be someone in your leadership chain, and the key is that they take a step back and listen. You know, like for the most part, I don't really need you to solve my personal problems, but I do need you to listen. If I have if I need to get it off my chest. I sit at this office for 40 plus hours a week, and I need to have that space to just talk and not feel like, oh, this person is trying to solve this particular issue for me. And so when I think of adaptability, I think of it in the sense of who's that person that can help me to be me in the space that I'm in, right? And it's not necessarily about you being somebody else in your organization. You need to be who you are 110%. And if that particular organization doesn't promote or value who you are, then you find another place to go work. I mean, all of us in here are extremely talented, and we can easily find other organizations to work in.
I just want to add that echo that Dan was saying. I think one thing very important, I'm talking about from the academic environment, is that we always encourage students to communicate, because nowadays, if you don't ask or they don't say or things like that, that will end up like falling to the crack. So communication, which is a very important part of it. Equally important, which is the listening. Just was saying that if we have somebody who can listen in just not necessarily solving the problem, but in terms of listening to what's going on, relate to the individual. That help a lot actually.
You know, looking back at my time at NOAA, I think it was a pretty interesting experience for me. Definitely a learning experience, and I think one of the most important things I did was actually just have an open door, open email, open phone policy where people could call or email. And I would say probably 98% of the time I had no answer. And they weren't looking for an answer. They just wanted someone to talk to. I still take calls and emails on a daily basis about people who just want to reach out and talk. And believe it or not, just listening is the solution that they're looking for.
All right, thanks for those answers. One more?
Yeah.
Oh, sorry, Mike.
Yeah, I'll get in on this a little bit here. I agree, Neil. The second year this year, since I came back to NOAA for my second time around, the National Weather Service has a mentoring program. And I really enjoyed that, working with two different people last year than this year. But they make a good point in that program, and others have said it too, that there is a understandable human nature to want to see people that look like you, but all your mentors shouldn't look like you. You know, you should seek out people that don't look like you. I mean, Danae just talked about one of his mentors being Bill LaPenta. There's a lot of us that have really worked with and valued other folks, and most of the time, almost every time, I've seen someone ask for a question or ask their opinion. Not like formal, will you be my mentor? But hey, can I talk to you? I've rarely see anybody say no. And almost always accepting of who they are. So it's a two-way street. So this is one of the things that a lot of us scientists can be, highly functioning introverts, or some not so highly functioning. I think I'm kind of like a middle of the road. But I mean, what is it? People have to take ownership of their own career and frankly, reaching out to those that you think you can learn from and be accepted by, I think is something that we have in our power to do. And I've really enjoyed doing that. I mean, over the last 35 years of my career, as I've had an opportunity to be a mentee and a mentor over that time. And the diversity of the people I've interacted with in this field has definitely increased steadily in that time period.
Any other comments? All right, let's move on.
So, yeah, I'd like to thank Danae for taking my phone call. And I'm Robin Webb. I'm the director of the Physical Sciences Laboratory here in Boulder. So welcome to Boulder. We heated it up for you. One of the things that struck me was the sense of inclusion. And I think that one of the strong things we have, and I question whether we have enough of, are the cooperative science centers, because they are community of inclusion. And so my question is, does NOAA have enough of them? We heard Mike talk about data assimilation. We heard Shaquila mention 4 of the 5 line offices, I think. OAR doesn't have one, minor detail. So is that a pathway that this community could work in terms of, we need more of these cooperative science centers as these sort of communities that we can grow and give inclusion from?
I think Rob just read my mind. Yes, I think the point I was making, that there are 20 plus cooperative institutes but only 4 centers, is alluding to the fact that we do need more CSEs. Perhaps this could be an example of how we can bring community of modelers together and create a CSE that can be assigned to OAR. And in my experience, we are mandated to do a NOAA experiential research opportunities for our graduate students, which serves as a pathway to future workforce. And I am, even though we are assigned to NESDIS, and pardon my NESDIS friends here, we had most NERDOs within OAR. So I think having a CSE that can reside within the research arm of NOAA, which is OAR, or whether program office for that matter, I think that would be a great way to do it. Or even build the capacity within the existing CSEs, because creating a CSE, it took 20 years for us to be where we are. So creating a new CSE may not take up the momentum, but perhaps create more bandwidth for the existing CSEs can also be a way out for that.
Yeah, I just want to add on. I think I don't have an answer for this question actually, because it's the structure of CI and CSC are, one is bottom out, the other one is top down. In terms of creating more CSC, that would be another level of discussion. But I do agree what Shakira was just saying, that how to expand our capacity with current CSCs, that is actually one immediate thing that we could do.
What I was going to say, and this is just from my understanding, I can be totally wrong on this, but what I understand is that CIs get much more funding than CSCs. And how about increasing the funding for CSCs so that they can expand and put it at least an equal playing field for them to receive that type of funding?
So that is a wonderful thing that Bill pointed out. One of the things that we're speaking about inclusion, this is the panel, the Bipartisan Infrastructural Funding, or the Inflation Reduction Act funding, we don't know there's a mechanism where CSCs can apply for that matter. But CIs can apply. They have task orders, that's how the cooperative, it's the administrative legalities probably which could serve as a barrier in order to achieve the success or attain the gap that we're talking about. So I think it is, again, a top-down approach is how the leadership would think about removing some of those barriers, for example. So we can also understand, because we do work with the communities, we are that conduit or the agent for the agency and academic partners for so many years. And we know in all where DEI is the soul of what we do. It's not an afterthought for us. We know what works and we know what doesn't work. So I think having that kind of a bandwidth where we can really understand what's the mechanism or pathway where we can really work together is really critical.
All right, Tamara's been standing a long time, so I'll let her ask her question. This will be the last one, I think.
Hi, good afternoon. For those that don't know me, Tamara Battle, Weather Program Office. I'm going to pivot because many of the panelists spoke about K through 12 and accessing or really tapping into that resource at the K through 12 level. But a barrier is K through 12 education. It's standardized, and that's actually also an issue at the undergraduate and even graduate level for a lot of the curriculums when it comes to atmospheric sciences and so on and so forth. So with K through 12, and I used to be a GK-12 fellow, a NOAA GK-12 fellow, where I would go into the classroom, and we were supposed to go into the classroom as scientists that would help students, but it was so difficult to fit within the curriculum of what they have to get through in that 9-month span that they have to stay on task. So how do we, what would be a suggestion, one strategy or thought of how we infuse ourselves into connecting at the K through 12 level if we can't go about working to change the curriculum of K through 12 education? And a lot of schools don't have the room to fit in and let's let NOAA come in for a week. They can't, because they have deliverables that they have to hit in order to get students to the next grade level. So what would be a way to tackle that?
So in the Weather Service office, we do a lot of school talks, but when it comes to weather, you know, it's the curriculum. I know weather is taught pretty much in 4th grade, and then it's hit again in 8th grade. At the high school level, there's, you know, you may get a little bit in physical science, but it's not really taught at that level. And at that level, a lot of students are kind of deciding what they want to do anyway when they go to college. So we really focus in on those 2 grade levels, the 4th grade and the 8th grade, and trying to educate them about what we do at the National Weather Service and the opportunities that we have in the Weather Service, and then talk about weather safety as a whole and in general. We touch other grades, but strategically for years, I really focus in on the 4th grade and then the middle school level, the 8th grade level. And so I think that until they change the curriculum. Now, you have other grades that may talk about weather. You may have a teacher that may bring up weather. Usually if a teacher's interested in weather, they'll find a way to put it in their curriculum. But knowing what levels that weather is really taught at is a critical key to know. And so 4th grade and 8th grade are those 2 levels that is really, really focused in on.
So I'm going to answer your question, but Bill's point actually made me think of a funny story. So I've got a 3rd grader and a 4th grader, and the 3rd grader, when he was a 2nd grader, took this test, and it was called "Which of these things are science, or which of these things are not science?" And it was cut out images of different things. And in the not science, he had like a rocking chair, like an airplane, and then he had a storm cloud with rain. And I was like, why is this not science? And he goes, well, my teacher said science is always right and your forecasts aren't always right.
All right.
So the short answer to your question, AMS has a program, a K through 12 education program, but they're not actually it's not aimed at K through 12 students, it's aimed at K through 12 teachers. And I think that that would be like a perfect path to take, because as we see a shift in the lower grades of focusing more on teaching things like climate change and environmental stewardship and stuff like that, the teachers are looking for material. They're looking for ideas and ways to teach this. And going through AMS, I think, is a perfect path.
All right, 30 seconds.
So before we end, I just want to say thanks to the planning committee for putting this on the first day, this particular conversation. Usually this is a conversation held for the last day when everybody is gone. So I just want to say thank you.
Also, thank our panelists for having such a thoughtful and insightful discussion. Thank you.
All right, I have so many thoughts and not enough time to share them because we have to move on to the next presentation. We're going to welcome our Wings Dissertation Fellows now. First, I'd like to introduce Dr. Cindy Bouillère. She is the Deputy Director for the Cooperative Programs for the Advancement of Earth System Science at UCAR, and she has a background in climate change and extreme weather. She is going to introduce the WINGS program so that we get a better idea of what it is, and then she'll introduce to us our WINGS Dissertation Fellows who will talk about their research. Thank you.
This late, and I know there's food outside, so I'm glad that you are still inside. And I know there's food outside, so I'm glad that you are still inside. It's my extreme pleasure today to introduce the WINGS program. WINGS stands for the Weather Program Office Innovation for Next Generation Science Fellowship. So it's a mouthful. It is the NOAA PhD candidate program, and it is brand new. I'm not going to be up here long. I'm going to be on and off so that you can meet the fellows. Is this supposed to work? There we go. I want to start off by saying thank you to a lot of people. There's a lot of people in this room. There's a lot of people probably online and a lot of people that's not here that has been involved in making this a realization. So thank you, deep felt thanks to everybody. The ones that I have up here is from CPAS. I also have the NOAA Weather Office Program folks on here, as well as our mentors. I know some of them is in the room today. Thank you very much for stepping up to be mentors for our students. Anybody in the room that wants to be a mentor going forward, let me know. We absolutely want to make sure that we grow the cohort of mentors. There's a list that's not on here, and that was our selection committee. Did not put them up because they're the folks that work in the background. You know who you are. There's a number of you in the room today as well. Thank you very much for the work that you've done in the background. So what is this program? This is a partnership between UCAR and NOAA. And the WINGS Fellows is specifically designed so that our fellows can gain insight and real-world experience while they are still PhD candidates. It is also a way to integrate them into the workforce, introduce them to NOAA, make sure that they understand what NOAA is, and that NOAA is an option for them in the future as they move into their careers going forward. This is our inaugural here. So we are focusing on a very, very narrow strip here. We are focusing on EPIC. This does not have to be the case in future. We can grow this, and the next call for fellows will be in the fall. So if anybody is interested in supporting a fellow going forward, we would love to hear from you. So those were the topics that we have this year. And I also want to say, so who is these fellows and what experience do we expect they're going to have while they are fellows? It is designed for PhD candidates, so we are specifically looking at those candidates that have done their coursework and is busy starting with their writing of their thesis. The fellows will continue at the universities. They will continue with their current advisors. We are adding a mentor, so anybody that's either from NOAA or that is associated with the USS, we welcome as mentors. It's a 2-year program, as we anticipate this is the last couple of years of their fellowship. And I want to end off by saying I lead the program in CPAS, so if anybody wants more information, reach out to me. And I also would like to introduce Kate Rudd, which is sitting in the back there. Kate is our program coordinator and is working extremely closely with our fellows. That's all I have for today. What I do want to do before I step off here is introduce our 3 fellows that's going to give you some of their highlights and what they are planning to do going forward. And this is the order in which they are going to speak as well. So our first fellow is Emily. Emily is working on surface winds and dust emissions, specifically looking at model parameterizations. Emily is from the University of Maryland in Baltimore, and Adriana is her advisor, and I think her her mentor is in the room today as well. Shreyas is looking at the origins and evolution of monsoon, specifically how to integrate this into UFS going forward. He is from the Carolina State University, and Antheas is his advisor. And last but not least is Joey. Joey is looking at exploring new satellite bias correction methods, also with a pathway into UFS. He's also with the University of Maryland, but he's with a different group. He's with the Department of Atmospheric and Ocean Science. And John, which I believe is online, is his advisor. So with that, I would like to pass it over to Emily.
All right, hello. Can everybody hear me all right? Awesome. I'm going to test this out because nobody gave me a tutorial. Here we are. All right, so like they said, I am Emily. I'm from the University of Maryland, Baltimore County. I'm really excited today to tell you a little bit about what I do to help improve the unified forecast system and what I use out of it, as well as some NOAA data, and we'll slip some NASA data in there as well. So I look at the intersection between measurements and models, and what I'm trying to do is improve model parameterization at the end. And so what I've done is combine 10-meter wind speed measurements from the ISD. If you guys don't know what that is, I'll tell you about it in a minute. And the go-kart dust emission model, which everybody's already alluded to. So I'm really excited you guys are primed for this. You'll see a lot of math here in a second. A quick outline of the talk so nobody gets lost. So I usually talk about the model introduction at the beginning, and what I'm going to do is break it into 2 parts. I'm going to break it into the go-kart dust emission model, and then I'm going to briefly talk about functia, which you guys will hear a lot about this week as well, and then talk about kind of some novel methods that we came up with for this study. And I'm going to, since we're close on time here, I'm going to combine some of my first chapter kind of preliminary results, and we're going to talk about what I'm going to do for the next 2 years too. So bear with me as I switch between this is what I did, this is what I'm going to do. So for those of you who don't know, mineral dust is really important in our atmosphere. This 35% of continental aerosols comes from the Sahara Desert and makes up a huge amount of the aerosols circulating around the planet at any given time. There's lots of sources. The biggest one is shown here. This is the 2020 Godzilla dust storm. If you guys remember any of that, you probably breathed in a little bit of it. But there's other dust sources like the Middle East and the American Southwest. This can impact everything from hurricane formation, human health. My fun fact that people ask me about all the time is, Emily, what do you mean dust is important? I said, you wouldn't have a rainforest without this dust emission. It's real important. And these areas are also changing dynamically as we move into a new climate world. So this is the go-kart model. Many of you will have fond memories of this one. So this is the global ozone chemistry, aerosol, radiation, and transport model. It's used in the GEOS model, so this go-kart is really a scheme within this model, and what it does is it takes the wind and saltation and suspension creep, all of those factors, and turns it into code and physics in our case. And this outputs a lot of different things. You can run this at any different scale and do all kinds of outputs. But what I'm using is the Mera-2 reanalysis, which is using model and inputs data from actual measurements. One of the first things that we did at this project was had to find a data source that wasn't actually assimilated into this progress. ISD is not, at least over land, which is important because that's where the dust is. So let's get into it. This is kind of what the go-kart model looks like if you look at the inside, if you crack it open. What you'll first find is this thing called the threshold friction velocity. Anything above this, you'll have dust emission. Anything below it, nothing really gets off the ground. And it was based kind of off of the Marticarena and Bergametti paper back in 1995, which is that curve that you see on your right, left, whichever one that is. And the go-kart model only uses this thing, the size bins that are in this teal square. The other thing that you need is the soil surface wetness. So that's what that omega term is in that first box up top is the soil surface wetness. And this was modified by Paul Janot and accounted for some soil parameters as well. So this is what's kind of introduced in go-kart. Then after you get the threshold friction velocity, you need to combine it with 10-meter wind speed and what's called a source function. And once you get all of these things together, you can throw it into the flux calculation, and you can get an emission output. The source function is a topographic source function in the go-kart scheme, and what it basically boiled down to on a physical scale was somebody saying, hey, there's some dust there, there's not as much dust over there, and this is just a number between 0 and 1 that for whatever grid box you're dealing with tells you how much dust is available to be emitted even if you pass this threshold friction velocity, so that's why you see it mostly attenuated there. The other important thing is this 10-meter wind speed. You absolutely need the 10-meter wind speed. It's gonna be scaled down in the Mera-2 model from like the 60-meter wind speed on a logarithmic scale, but that's really critical to this model. And as you can see in the flux equation, it's actually a cleverly disguised cubic. So when you get small differences in this 10-meter wind speed, either in the metal between the model and the measurements, you wind up with a large difference on the flux. All right, so I told you I'd talk about Functia as well. So Functia is a new operational model in the UFS aerosols and GEFS 13. This is the equation that they use, that Functia is using on the other side of this slide, and you can see it's pretty similar. It uses threshold friction velocity as well as particle size, and then what it does is actually take the soil composition, and it's a little bit backwards from go-kart. It actually applies the Koch distribution, and you end up getting the flux on the other side. So now that we have all the building blocks together, so that was like the first year of my thesis where I was like, what is all of this stuff? What I wanted to do once I learned about all of this is to better understand the limits of these parameterizations that are going on between wind and dust. And I wanted really especially to be able to quantify these differences, especially on a subgrid scale, because that's where we're going to be able to see real differences that we could make in the parameterizations kind of at the end of this. So that's when I came up with the wind study. This is a backronym for those of you who know what that is. You'll have to excuse the two I's. It's a wind study that leads to a dust study. So what am I doing? These two maps are from the Integrated Surface Database. So these are meteorological stations that are scattered all over the planet, and they have 10-meter wind speed. In this case, what I'm showing is 10-meter wind speed for the last 20 years. And these are all stations that I verified are at 10 meters, and they have data in like every month for the last 20 years. They're statistically significant. Some of them that I'm going to talk about, especially for this talk, are the pink ones in the Middle East desert regions. This is a huge dust-emitting region for the planet. There are 31 stations in that map that we're going to be talking about here. And in order to get them to work well with the go-kart dust emission scheme, what I've done is kind of make my own little database out of it. So what I've done is anytime that I have an ISD measurement, I go and grab the Mera-2 reanalysis data point for that exact same time. Sometimes there's sub-hourly measurements, those get combined, and sometimes there's no measurement at all. So if I don't have a measurement at 1 p.m., then I'm not grabbing the Mera-2 measurement there. And so that way you can really get an apples-to-apples comparison between measurement and model for a climate-significant time period. So this is kind of first chapter stuff. So this is where I'm going to start saying, this is what I did for a little while. So this is Middle East. At the beginning, I just graphed everything that I possibly could, and this ended up being the monthly mean average for 20 years. The orange is the MERA-2 reanalysis. The ISD is in blue. There's the standard deviation shown top and bottom, and the kind of more important number that is sitting on the blue line. This is what's telling you if it's a full data set. So if you do 365 times 20 times 24 hours a day, you should get around 14,000 data points. That's what we're dealing with here. So all of these stations are really good stations to look at. And once I laid these out, actually on my advisor's desk one day, and we spent a couple hours looking at the patterns and sorting them. And in the Middle East especially, we started seeing kind of these four different kinds of stations. So there's an agreement and various disagreements. And you can see that there might be different physical parameterizations going on in like the summer and the winter that would affect these differences. And then broadly what we saw is a lot of MERA-2 overestimation. This is a pretty big category. And this is on the order of 2 meters a second. And you can see that pretty uniformly across the Middle East, that when it's different, it's on the order of 2 meters per second. And like I said, that gets cubed in that flux equation. So this ends up being really significant. So the other thing I wanted to do is be able to quantify how much different things are on a subgrid scale. So our method to doing that is to look at all of the grids with more than one station in them. This circled grid is one of them, and the two plots on the right-hand side are similar to the plots you've already seen. And you can see here that they actually are pretty similar. This was really exciting to see. MERA-2 overestimates a little bit on them, but overall they follow the trends. And really interestingly, that bottom plot, you see ISD kind of shoot up in this more or less dust event, and MERA-2 goes right along with it. I was really interested when that plot popped out. Another grid that we had an opportunity to do with these two stations, where it's in this southwest corner. So this one, completely different story, right? So this doesn't really match in June, July, and August, which is typically the dust season in this region, and again has a MERA-2 overestimation, and again also has a statistically significant number of data points available for analysis here. So this is something that we are hoping to do further, primarily in the American Southwest is really important coming up, and in other dust emitting regions as well. So this is a tool that we've built out in order to do that. And finally, we've gone from wind to dust now. So everything up until here I've shown you is all about wind, but like I said, it propagates to dust mass emission via that cubic. It's really important. So these are those 30 stations again in the Middle East, and this is on the other side, the dust emission average for 20 years. So this is the average dust emission difference that you would expect to see on any given year this is a meter squared plot. And so each of these numbers on the left match the numbers on the right. And so you can see this trend between the southwest and the northwest region as well. And then so the orange bar plot here is the absolute difference between the two. So ISD minus MERA-2. So if you see a positive difference here, it means that the ISD is showing more emittance than MERA-2. And if you see a negative, vice versa. The other interesting thing that I decided to plot on top of this was kind of for my own sanity, because I wanted to know what would happen if I plugged those 10-meter wind speeds from ISD back into GoCart and see what pops out on the other side. And since I didn't have GoCart to actually run that, I built a little segment of GoCart myself in Python, and this is kind of what popped out on that side. So this blue line is the percent difference to the MERA-2 reanalysis emissions that you would expect to see if you plugged in the ISD wind speeds. And just to help my own sanity a little bit more, I am a modeler, and my advisor is an experimentalist, so I wanted to see what this actually meant, right? This is what this actually means. So I went into the lab, which is uncommon for me, and I actually went and got her, and I got help. And I was like, what does this actually look like? So this is a bottle of actual dust that was emitted. I believe this one was from the Sahara. She went on a trip there and came back with 56 grams of dust in this vial. And this is station number 8 that we're pointing at, and it has an average difference of 0.0575 teragrams per year, and this is on the grid box scale. This is not the meter squared. works out to be 61 grams per meter squared. So that's what that one looks like. And then I didn't have a bigger bottle, so you'll just have to believe me that station number 22 has an average difference of 0.1827 teragrams of dust emission per year, which on a grand scheme of things is actually really significant. Ends up being 73.08 grams per square meter per year. So this is, if you spread this out over a meter squared, MERA 2 might admit it, and ISD would not. All right, so some quick conclusions and future work. So this proposed study will try to understand dust emission differences driven by wind differences, just because we don't have a large amount of flux measurements on the ground. Though if you do, hit that QR code at the bottom. I'd love to hear about it, and we can incorporate it into maybe a collaboration effort. But I really want to go forward and understand global and local biases. So like I just showed you all of these Southwest stations, I'd also love to look at stations in the Southwest and in the Sahara, the Gobi Desert. And this will help inform future parameterizations that'll help work best for the UFS in a climate-ready future by identifying these local discrepancies, global intercomparisons, and hopefully that third chapter of my thesis is comparing to in situ data if you'd like to share. And I'll finally show you me in my home environment here. So this was in White Sands National Park a couple weeks ago. They thought it was a great idea to fly out about 150 dust scientists to the middle of the desert. It was. So this is me really excited. You can see me pointing at, this is a dust devil on your left here, and a dust storm showing all of this red on the other side, and me just being happy as a lark in the dusty environment. Thank you so much.
All right. So my PhD research topic and my dissertation is on the origin and evolution of the monsoon onset vortex and its subseasonal impacts. So it's a combination of a lot of observational study and observational analysis as well as a modeling effort. And it would involve integrating theory and predictability studies using the UFS. And I work with Dr. Anantha Iyer at North Carolina State University. So going right into the concept of the monsoon onset vortex. So in order to understand what is it, first let's get a brief overview of what is the monsoon itself. What are the brief salient features of the Indian summer monsoon? So it's a 4-month season spanning from June to September. And it is characterized by the masculine high or the high pressure over the southern Indian Ocean. And you have the Somali jet, or it's the low level westerly jet of the eastern coast of Africa or the southwestern part of the Arabian Sea. And it's a very strong low-level jet and accounts for roughly 50% of the cross-hemisphere mass transport in the world happening during the months of July and August. Next, you have the tropical easterly jet, which is an east-to-west jet stream at 200 millibar level. So unlike other regions of the world, this particular region sees an easterly jet stream for the 4 months of the year from June to September. And you have the high pressure sitting over the Tibetan plateau, which is a very high altitude plateau of 4,500 to 5,000 meters above sea level. So these are the salient features of the Indian summer monsoon. Now coming to the question, what exactly is the monsoon onset vortex itself? So as the name suggests, it's a vortex which is forming during the onset of the Indian summer monsoon. So we know that the monsoon is characterized by high vertical wind shear as shown in the images in the previous slides, because you have strong westerlies at low levels and strong easterlies at upper levels. And as a result, tropical cyclogenesis is rare during the core monsoon months of July and August. But during the onset phase of the monsoon, a vortex or a strong low pressure system forms in the Arabian Sea during late May or early June, which is typically the onset phase of the monsoon. And this occurs in around 60% of the years. So not all years you will see an onset vortex developing, but roughly in 60% of the years you will see this particular synoptic feature which develops. And this vortex has been termed as the monsoon onset vortex in previous studies. And you may recollect a recent example of Cyclone Biparjoy, which happened in June this year. And this is an infrared image of the same. And it was the longest lived tropical cyclone in the North Indian Ocean basin, and particularly in the Arabian Sea basin. Its translational speed was very slow. So this was a recent example wherein you saw an onset vortex this year, whereas last year there was no onset vortex. And this slide here just shows a comparison of 2 consecutive years wherein you had an MOV during the onset of the monsoon. The one on the left is in June 2015, whereas the image on the right is June 2016. Immediately next year, you do not see any tropical system forming in the Arabian Sea. And it was a smooth monsoon onset without the formation of an onset vortex or a tropical cyclone. Now the question arises, like, why do we study the MOV? What's the usefulness of this particular study? So number one, it affects the advance of the monsoon, because the first thing is it may help in setting in of the monsoon over southern India, because it organizes convection on a large scale, and as it moves polewards, it drags the southwesterly monsoon winds along the west coast of India. And the other thing is the intensity and track of this particular disturbance can possibly delay the monsoon progression over the west coast of India, because if it travels in a westerly or northwesterly direction, as usually happens with the tropical systems in the northern hemisphere, then it may drag away the monsoon winds towards it, and the west coast of India may receive deficit rains during the initial subseasonal part of the monsoon season. The other is considerable socio-economic impacts. Of course, the primary one is because of the lack or the excess of the rainfall that it may cause if it either makes landfall over the Indian coast or moves away from it, and then you have a lull phase in the advance of the monsoon. So that is one impact, and of course, it often intensifies into a tropical cyclone. So even though the onset vortex is a low pressure system, in more than 80% of the cases, it becomes a tropical cyclone. And that is a coastal hazard for the densely populated coastline, as well as the Arabian Sea, which is an important basin for trade routes, especially related to oil and for the entire world. And past MOVs have caused damages worth $4 billion. So one of the MOVs in 2007, which intensified into a super cyclonic storm, that caused a lot of fatalities across different countries bordering the Arabian Sea and caused immense damage to life and property. And of course, the agriculture and hydrological impacts through modulation of subseasonal monsoon rainfall. And let's have a look at what has been the previous literature and what are the knowledge gaps which I plan to address as a part of my PhD dissertation. Previous studies have focused on idealized modeling experiments. You had single-layer barotropic model to study barotropic instability of the Somali jet. So it was hypothesized, and it was studies had mentioned that the Somali jet is barotropically unstable, and that's why you have the formation of a vortex to the poleward side of the jet. And some studies have also looked at dry barotropic baroclinic instabilities of the basic state, and using models with 2 or more atmospheric layers. And some studies have looked at the synoptic aspects of the environment in which the monsoon onset vortex forms. That is the Arabian Sea mini warm pool. You have an exceptionally warm region in the southeastern Arabian Sea with sea surface temperatures often exceeding 30 degrees Celsius during the formation of the onset vortex. So studies have looked up whether this mini warm pool plays an important role in the formation of the onset vortex, or is it the Somali jet or the positioning of the Somali jet with respect to the mini warm pool region. So that's what some of the previous studies have looked at. However, there has been no comprehensive study which has focused on physical mechanisms of the MOV formation and its impact on the subseasonal monsoon rainfall. And the other big knowledge gap is the predictability of the MOV. The big question as to why the MOV forms only in certain years, and can the global weather prediction models correctly simulate this particular feature of the Indian summer monsoon. So one of my objectives of my PhD dissertation is to evaluate the performance of operational models such as the UFS. And having a quick look at some of the preliminary results,
The challenge was to first come up with the list of the past MOVs, because there has not been any particular database as such, documenting all the MOVs since the satellite era. And that's why, I used a combination of reports from the Joint Typhoon Warning Center as well as the India Meteorological Department, and I've identified 23 cases of monsoon onset vortex since 1982 onwards till 2021. And if you consider this year, then it's the 24th case. Next important aspect of predictability in the tropics, or the variability in the tropics, is the Madden-Julian oscillation, and especially over the Indian Ocean region, where the MJO is one of the most dominant factors of intra-seasonal variability. So what is the role of MJO in the formation of the monsoon onset vortex? And what we found out was the response of the MOV towards the MJO phases is non-linear. That is, a convectively active MJO is neither a necessary nor a sufficient condition for MOV formation, whereas a convectively suppressed MJO suppresses or inhibits the formation of the monsoon onset vortex more robustly. And this is one of the recent research, and the manuscript is under review. And this basically tells that although MJO governs the formation of tropical cyclones in the North Indian Ocean to a great extent, it may not be a major factor governing the formation of the monsoon onset vortex. And the response of the monsoon onset vortex towards the MJO phases is non-linear. Next part of my, some of my preliminary results is flavors of the MOV. So not all monsoon onset vortices have a similar structure or similar intensity. So what I thought was to classify the MOVs into different categories, and this is a part of an ongoing work. And presently I'm working on analyzing the MOV structure using high resolution reanalysis datasets as well as some satellite observations. And we hope to come up and document some flavors of the monsoon onset vortex. And the ultimate goal of this particular objective is to develop a synoptic model of the MOV so that we understand its structure in detail. Next, coming to some of the model simulations, I have simulated some cases of the monsoon onset vortex using the WRF model, or the Weather Research and Forecasting model. And the key findings are that just the barotropic instability of the Somali jet is not necessarily an important factor in the MOV formation, but you also need surface enthalpy fluxes from the ocean to sustain and intensify the MOV into a tropical cyclone. And the simulations of the monsoon onset vortex in the WRF model were sensitive to the choice of convective parameterization schemes used. So different schemes, the simulations resulted in the MOV of a completely different intensity, and some schemes did not even intensify the MOV into a tropical cyclone, whereas the actual observations had a tropical cyclone in those years. And these are some images from the WRF simulations. Like if you turn off the surface fluxes, then the amount of accumulated precipitation is drastically reduced, and the panel on the right shows the winds. You do not see a cyclonic system developing in the Arabian Sea. So just the barotropic instability of the Somali jet is not sufficient for an onset vortex to develop, but rather the oceanic contribution is pretty substantial, is what this particular set of analysis has showed us. And coming to the proposed work with the UFS, so for this, as a part of the Wings Fellowship, I'm working with Dr. Christiana Stan, as well as my advisor, Dr. Ananta Iyer. And an important aspect is validating the UFS performance, validating the performance of and the forecast skill of the prototypes of S2S predictions, seasonal to subseasonal predictions of the UFS, and compare them with reanalysis datasets and observations, and see if the UFS prototypes are able to capture the formation of the onset vortex and the variability in the subseasonal monsoon rainfall as a result of the onset vortex. And analyzing fields such as wind, vorticity, and thermodynamical fields like temperature, sea surface temperature, and cloud properties and rainfall is what I would be doing as a part of the Wings Fellowship. And after this analysis, I'll get an idea of what is the model bias, how well is the UFS performing with respect to this particular synoptic phenomena. And the other part of the proposed work could deal with potential simulations using either the UFS short range or medium range weather applications. And that will help in, again, checking the predictability of the MOV using the UFS. and also help in studying the mechanisms which govern the formation and intensification of the MOV into a tropical cyclone. So if I could simulate the MOV using either of the UFS, SRW, or MRW, then it would help in understanding the mechanisms through which the onset vortex becomes a tropical cyclone, or why do some onset vortex do not become a tropical cyclone. And lastly, summarizing the usefulness or the applicability of this particular research is the impacts on global science, meteorology, and the community. First thing is it will help in improving the UFS and the sub-seasonal predictions of tropical monsoon regions. And this would be a step towards achieving the objectives of UFS as well as NOAA, which is to help improve the skill and enhance the value of sub-seasonal weather forecast. And since most monsoon onset vortices intensify into tropical cyclones, this particular analysis would potentially help us in understanding a new pathway to tropical cyclogenesis. That is a pathway which is linked to the monsoon's existence itself, like it is the monsoon wind pattern which gives rise to the onset vortex which becomes a tropical cyclone. So this is a unique subset of tropical cyclones, and understand a potential pathway, like is aggregation of convection playing an important role, or is it any type of barotropic or baroclinic or moist barotropic or moisture vortex instability, or what other mechanisms govern the formation of this particular synoptic feature. And this, improving the forecast of this particular synoptic feature can help in improving the forecast of other regions of the world, because through teleconnections, as the convection in the tropics and especially in the monsoonal regions of the world tends to affect the weather in different regions of the world through teleconnections and changes in the wind patterns in the downstream and other directions. And improved sub-seasonal weather predictions would definitely be of great help to the food and water security in the South and East Asian regions of the world. And this would ultimately help in minimizing socio-economic impacts and benefiting a large section of humanity. And finally, I have a lot of people to acknowledge. Firstly, I would like to thank CPAS, UCAR, and NOAA Weather Program Office for this incredible opportunity. I would like to thank my advisor, Dr. Anant Iyer, for his constant support and valuable guidance. My PhD advisory committee, Dr. Gary Lackman, Dr. Walt Robinson, and Dr. Sarah Larson for their valuable feedback and support. My mentor of the Wings Fellowship, Dr. Christiana Stan, for her guidance on the UFS. And lastly, Dr. Cindy Brewer and Kate Rod from CPAS for their immense work and support, and helping us walking through all the onboarding process since last 4 months. And with that, I am open to questions.
I'm sorry, we don't have time for questions, but I would love it if after this, for example, at the networking dinner, perhaps you can all get in touch with your fellows. Joey, you're next? Yes. Great. Go ahead. Take it away.
Thank you for having me. It's an honor being here and an honor being chosen as one of the fellows. Right, so today I'm going to be talking about satellite bias correction, both within theoretical and operational frameworks. A reminder, I'm from University of Maryland. My advisor is Dr. John Potterjoy, and I also have extensive collaborations with some folks at NRL Monterey, namely Dr. Elizabeth Satterfield and Dr. Bill Campbell. Now, my PhD work has primarily been focused around satellite radiance bias correction. We all know that satellite radiances contain a great deal of information about our atmosphere. They're particularly invaluable for TC forecasts, given that TCs, tropical cyclones, develop over open ocean, where in situ measurements are relatively sparse. But satellite radiances are biased, and they require bias correction. Now, in global models like the GFS, this is often performed in an online manner. Bias estimation and correction is performed as we run the model. But in limited area models, that's often difficult for a number of reasons and often not performed. The main reason we found is namely because of a lack of fully cycling DA over the entire domain, which is definitely necessary for that kind of bias estimation. And so instead, oftentimes models, I'll take HWRF as an example, instead borrows bias parameters from a model that's trained externally, usually a global model. But this is kind of problematic because bias specification is strongly model dependent. The techniques that we have cannot easily separate model and observation biases, and so that's a problem when you're importing that bias information. And so the practical part of my presentation was to test a fully cycling clear sky radiance bias correction method for the halves model, and I'll talk a little bit more about that now. Now this was, these experiments were initiated back when halves was still very much in development. And so some of this is similar to the operational halves that we have today, and a lot of it is different. But for the sake of time, I'm just gonna highlight a few different aspects of the halves configuration that we used. Namely the DA portion, we're using a 3D ENVAR system, 6-kilometer resolution, and for background error specification, we are borrowing the 80-member ensemble from GDAS. I also wanted to point out this is tested over a 5-week period during the 2020 TC season, and so this covers 8 TCs from Laura to Sally. Now this is the GSI Clear Sky VAR-BC model. It's pretty simple. I'll just walk you through it real quick. We're applying the bias correction to the ob space prior, and the bias model is there. It's pretty simple. It's simply a weighted sum of these predictors, P, which are a function of atmospheric, or function of model state, rather, as well as these, excuse me, as well as these weights, beta K. And these weights are the subject of our experiments. Now, for the online experiments, and again, you know, in global models that perform this estimation online, we're estimating these beta weights, each analysis given innovation statistics, and we're doing it via a variational framework, which I'll refer to as a VAR-BC framework. I don't have the equation here, the cost function, but it is in my supplemental slides if anyone's curious. And we're contrasting this against a control experiment where instead these weights are adopted from an external model, in this case, GDAS. Now, I'm just gonna kind of fly through my results, and I think they speak for themselves. We have the control experiment here in red and the online experiment in blue, and we're looking at model forecast error statistics, specifically track, max wind, and SLP. And you can see that the online approach leads to an improvement in TC track and intensity forecasting, particularly track. And if you look at, we also took a look at a subset of TCs, and we call these the well-observed storms. And they're essentially just storms that contain numerous inner core observations, normally dropsons and TDR observations. And we see that the improvements strengthen with such storms, and we think it's valuable because you know, these are not just high impact events that we choose to, you know, fly these planes through the storm center for, but also it makes sense if we have this better characterization of the large scale atmosphere, which is, you know, in part due to this online bias correction method, and it pairs really nicely when we have these really valuable inner core observations, kind of filling in the blanks. Right, and so I actually just published this, or rather it's in the process of being published. This is the title, Implications of Self-Contained Radiance Bias Correction for Data Assimilation Without Halves, kind of a mouthful. And wrote this with my advisor, John Potterjoy. It's coming out in Weather and Forecasting, DOI, and QR code there if you want to check it out. All right, now on to the theoretical part of my presentation, and right on time. So VAR-BC bias correction schemes are nice, but they have one issue, which is they correct to a model background. And in the case that we have zero model error or bias correction, that means that observation bias correction, or sorry, zero model error, then the bias correction would be pretty trivial, but as we all know, our models are biased. And so when we have an undiagnosed model bias, the bias correction schemes are subject to something called bias reinforcement. And so we have a hypothesis that if we can correct the model bias independently of the model or the OBS bias correction, we can kind of mitigate this model bias reinforcement. And we have a strategy here, which is to first correct the model biases with a set of analysis increment statistics, and then later correct OBS with innovation statistics. And we're testing this idea out first in an idealized model, which is the Lorenz 2005 Model 3. I'm sure plenty of you are familiar with the Lorenz models. They're a set of dynamical chaotic models. They're used frequently within the field for such experiments. The Lorenz 2005 models, they each simulate a single scalar quantity at one level and one latitude. Model 3 specifically simulates smooth planetary waves with a small scale activity superposed. I have a snapshot of our ring to the left here. And you can see I pointed out the small scale, which is Y, and the large scale X, and then Z, which is essentially the superposition of both. And this model replicates a number of physical processes, or seeks to replicate a number of physical processes, including advection, damping, and some constant forcing. Oh, that's not right. Right, and so for our experiments, we're going to employ a 500 ensemble member ENKF based on the work of Whitaker and Hamill, and that's actually a typo, it should be 2002. We employ localization and inflation to deal with sampling error, and we tune it to achieve an optimal spread over skill. And we're designing these experiments to simulate challenges within operational NWP models, specifically satellite radiance assimilation. And so we're introducing a number of situations, sparse OBS, biased OBS. We're looking at kind of a land-ocean disparity, and so what that might look like is, half of the ring is observed and the other half is unobserved or only sparsely observed. We're looking into anchor OBS and seeing how that can affect the method and forecasts in general. We're playing around with model bias in the Lorenz models. And we're also examining how we can simulate representativeness error. And I included some figures to the left, which just display how these experiments change with a low and high model bias. Right. And so a little bit about these bias correction techniques. So we're taking the analysis increment and innovation statistics. We're collecting that over a training period. We're time averaging them, smoothing them. And then we're examining 3 additive bias correction techniques. And so we're correcting model bias by just simply adding the model space prior with the analysis increments. And we're also performing OBS bias correction by taking these innovations and also residuals, and adding that to the OBS space prior. And then finally, we have our kind of novel technique in which we're trying to correct model bias and OBS bias independently. And the way that we do that is we first conduct an experiment where we have a biased model and we bring in perfect OBS, or rather unbiased OBS. They still have some kind of variance. And we assimilate those, and then we bias correct that, but we introduce some biased OBS along with that experiment. And then third, we take a final step and we take the innovation statistics that we collected from the second experiment along with the analysis increments from the first experiment. And the overall goal here is simply to try to correct as much model bias as possible so that we have a better characterization of our OBS bias when we perform OBS bias correction. Now, we're still collecting results, and for the sake of time, I'm not going to really get into them here, but our candidate technique has demonstrated some success in improving forecast accuracy over benchmark experiments. we're going to continue to refine this methodology and also explore, try to simulate, again, these challenges that we see in NWP. And the nice thing about this model is that it's really scalable to NWP systems, other UFS systems. It will rely only on time average analysis increments and innovation statistics, which is, of course, collected in any model. And so the next step is to implement this candidate technique in the halves DA configuration. And we're going to do that in combination with some other novel DA methodologies that are developed in our group at UMD, which you will actually hear about from John and Kenta later in this week. And so that's all I have for you, and thanks for listening.
Moderators, organizers, it's been a great start to what I think will be a fascinating week. A big thank you, of course, to EPIC for organizing this once again, and to UCAR for hosting. We are hosting a networking dinner at Avanti Food and Beverage after this. The address is in your event guide. I'm not sure if it's probably not. I don't think it's on the slide. Well, it's on slides from the morning. So best to check your event guide. Just a couple housekeeping things before we officially adjourn. We're expecting a larger crowd tomorrow, so there will probably be chairs around the edges of the room. We will also be starting in 3 parallel sessions. So there's in the South Bay, the short-range weather app, rapid refresh forecast system talks. The Center Bay, which is here, have the medium-range weather and sub-seasonal to seasonal application talks. And then in North Bay, I'm going the wrong direction. North Bay's that way, I think. You have the hurricane talks. So just check your guide, and I recommend getting here a few minutes early to figure out where you need to be. And I think that is it for me. So hope to see you later and or during the rest of the week. Thank you.